Good afternoon, everyone, and welcome to this exciting 8th General Assembly of the Copernicus Climate Change Service. Thank you for joining us here in this wonderful city in Valencia, and of course also online. Let me introduce myself because I'm going to be with you for the next 4 or 5 hours. My name is Marc Santandreu. I am a physicist, meteorologist, currently working as a weather broadcaster for the Spanish public television, so it's really an honor to be here with you, moderating and presenting this relevant event. Let me say as well that in our work, we dedicate significant effort to climate communication, which is becoming increasingly important. So the data provided by Copernicus in areas like flood monitoring, fire tracking, or global temperature studies allow us to do our job with greater precision and scientific rigor. So we truly appreciate the support and the quality of the information that Copernicus offers. Today's program is packed with inspiring talks and insightful discussions. We'll hear from leading experts in climate science, policy, and services, so I encourage you all to engage actively. Let me quickly go over some reminders. There will be a Q&A after each talk, so if you are following us online, you can submit your questions by scanning the QR code you're gonna find on display. You can join also the conversation on Twitter with the hashtag C3SGA25. You can share, of course, your feedback by completing the survey at reception or by opening the link you can find on YouTube channel. And the recordings of the events, as well as the presentations, you're going to find them on the website of the C3SGA once the event is done. And by the way, this event foresees coffee and lunch breaks. Today we're going to have also an icebreaker event, tomorrow a networking dinner. So let's begin with the opening session. To start, we are delighted to have several prominent institutional figures with us today. Their participation is a tremendous honor, and we thank them, we thank you for your invaluable contribution to the climate community. We begin with Carlos Mundina, Councillor for Climate Improvement and Water Management at the Valencia City Council. Carlos, the floor is yours.
Buenas tardes, muchas gracias. Enhorabuena a la organización por haber escogido la ciudad de Valencia y sobre todo este entorno que creo que es maravilloso, lo estábamos comentando antes del inicio, un enclave fabuloso de nuestra ciudad. Autoridades presentes, Ministra de Ciencia, Innovación y Universidades, Directora General del Centro Europeo de Previsiones Meteorológicas, responsable de Políticas de Copernicus. Señoras, señores, es un verdadero honor darles la bienvenida a Valencia con motivo de la 8ª Asamblea General del Servicio de Cambio Climático de Copernicus. Nuestra ciudad se siente especialmente orgullosa de acoger este foro técnico de referencia, en el que se dan cita instituciones científicas, agencias europeas, responsables políticos y expertos en adaptación climática de toda Europa. El cambio climático es una realidad tangible que ya está teniendo efectos directos sobre nuestras ciudades, nuestras economías y nuestra vida cotidiana. El pasado mes de octubre, en Valencia, tuvimos un claro ejemplo de este cambio climático, una tragedia y una situación que fue catastrófica con motivo de la dana, de las que se produjeron unas lluvias que en las últimas décadas nunca se habían registrado en nuestro territorio. Provocó precipitaciones torrenciales que acabaron con la vida de 228 personas y que afectó a infraestructuras básicas del área metropolitana de Valencia y a 3 de nuestras pedanías, en concreto a La Torre, Fort d'Alcedo y Castellar Liberal, muy próximas al Parque Natural de la Albufera. Este episodio nos recordó una vez más que la adaptación al cambio climático ya no es una opción de futuro, sino una necesidad presente y urgente. En este contexto, el programa Copernicus desempeña un papel esencial al ofrecernos datos climáticos fiables, continuos y abiertos, que permiten anticipar riesgos, planificar mejor nuestras ciudades y diseñar políticas basadas en evidencias. Gracias al acceso a estos productos climáticos estandarizados, proyecciones regionalizadas y herramientas de visualización, podemos mejorar nuestra capacidad de respuesta ante eventos extremos y tomar decisiones más precisas a escala local. Desde el Ayuntamiento de Valencia estamos firmemente comprometidos con esta visión. Nuestra ciudad ha asumido un papel activo en la lucha contra el cambio climático, alineando su planificación urbana con los objetivos del Pacto Verde Europeo y participando en múltiples proyectos europeos de investigación e innovación. En los últimos años, Valencia ha desarrollado estrategias pioneras de adaptación en el marco de proyectos enfocados en la resiliencia costera, la movilidad sostenible, la infraestructura verde y la participación ciudadana en la transición energética. Además, formamos parte de la misión europea de ciudades inteligentes y climáticamente neutras, con el ambicioso objetivo de alcanzar la neutralidad climática en 2030. Este compromiso se traduce en actuaciones concretas como el despliegue de soluciones basadas en la naturaleza, la renaturalización del espacio urbano, el impulso de la transición energética o la creación de zonas de bajas emisiones. Asimismo, estamos especialmente ilusionados con la candidatura de la Albufera de Valencia para que sea Reserva Mundial de la Biosfera, un reconocimiento que permitirá a este humedal acceder a estos recursos tan necesarios para mitigar los efectos catastróficos de la dana, y que esta joya de la ciudad y de los 12 municipios ribereños que, dejando a un lado diferencias políticas, se han unido por el bien común de su territorio para que luzca mejor que nunca. Colaboraciones como la que mantenemos con Copernicus son clave para fortalecer la integración entre la ciencia climática y la gobernanza municipal. Solo mediante una alianza estrecha entre la investigación, la tecnología y la política pública podremos anticipar con eficacia los impactos del cambio climático y proteger a nuestros ciudadanos. Para finalizar, les deseo y esperamos que esta asamblea sirva como espacio de intercambio técnico, inspiración colectiva y construcción de soluciones compartidas. Les deseamos unas jornadas de trabajo fructíferas y una estancia enriquecedora en Valencia, una ciudad comprometida con la ciencia, la sostenibilidad y el futuro climático de Europa. Muchas gracias.
Thank you, Carlos, for your words. Gracias, Carlos. So we continue. We are delighted to have Florence Ravière, an outstanding scientist and general director of the ECMWF, by the way, for the past decade. So, Florence, the floor is yours.
So, buenas tardes. Es un honor y un privilegio para mí abrir esta conferencia en la bella ciudad de Valencia. And now my Spanish will stop here. And I will continue in English to welcome the Minister, Councillor, distinguished guests, and partners and colleagues. So, special thanks to the Spanish Ministry of Science for the support and for hosting us today. In a country, of course, Spain, which is no stranger to climate change, with its, of course, challenges, but also opportunities. There has been incredible work, so we meet every year, and it's good to reflect on what has been done in the previous years. And there has really been incredible work being done by the whole community, the scientists, the engineers, the data providers, the partners and the users across Europe and beyond. It is your collective efforts that makes this service not only scientifically robust, but also operationally impactful. The recent release of the Copernicus European State of the Climate report for 2024, it was compiled this year for the second year with the WMO, the World Meteorological Organization, and it showed once again the importance of having data to document climate change. 2024 was the warmest year in Europe, with half of it really beating some records of heat. And 2024 as a whole for the whole globe was also the warmest year, and the first calendar year where the temperature was more than 1.5 degrees above the pre-industrial times. So, of course, it's not just about temperature, climate change. The Councillor discussed the impact it has on precipitation as well. And really, 2024, this was the most widespread flooding in Europe for the last decade, with a third of the river having at least the high flood threshold over Europe. Unfortunately, storm and flooding affected more than 400,000 people and with more than 300 deaths. But not everything is bleak, and actually the proportion of electricity generated by renewable energy in Europe also reached a record high of 45% in 2024. And I must say that Spain is actually doing very well in terms of renewable energy, with also 56% of Spanish electricity being coming from renewable sources, 2024 being again a record high. So this European State of the Climate report, it's fair to say that it has become a general benchmark reference, and not only for the scientists, the policymakers, but also for the general public and for the media. And it's not very often that you have scientists getting primetime television, but we certainly did, and the information from Copernicus on this European State of the Climate report appeared in more than 100 countries around the world. One of our main deliverables is the reanalysis, which reconstructs past weather and climate information from a combination of historic data, but the up-to-date as well weather computing models. So it's providing this complete and consistent picture of the weather and the climate from 1940 until now. We performed a recent socio-economic benefit study for the reanalysis, and it showed that the overall economic return from public investment is estimated to be at least 10 times, which means that the benefits really far outweigh the costs. And I'm quite excited about the ongoing preparation for the next generation of reanalysis, which we do every few years. This is a very ambitious project, and it will provide a broadest range of users with more accuracy and more precision as well. So ERA 6 is a bit like the younger brother of the old generation, the current ERA 5. It's more agile, but it's definitely determined to make its mark. In parallel, we are enlarging the multi-model, multi-system seasonal forecast suite. So this is providing forecasts for the next season ahead. It encompasses contributions from ECMWF, from France, UK, Germany, Italy, but also partners abroad like the US, Canada, Japan, and Australia. So with all these partners, it makes it more robust and more resilience to predict the weather for the next season, which is very useful for decision making. This work supports key sectors like agriculture, energy, in particular renewable energy, emergency planning, and beyond. So it's not just about going back in the past, it's also looking to the future. And for the two Copernicus services we are running at ECMWF, the Copernicus Climate and Copernicus Atmosphere Service, we are already planning for the next phase of Copernicus. And this has already started being discussed with member states, and these initial plans highlight our commitment to innovation, science, service quality, and user engagement. So, of course, Copernicus Climate is a service that works well, so we want to evolve in a bit of continuity in the service. So it's mostly about evolution of the service, but we are also going to embrace the artificial intelligence and machine learning revolution to see what they will bring to the surface, which I'm sure is going to be tremendous in the next few years. We will hear more from Carlo on Wednesday morning about the future of Copernicus. But as we plan ahead, we remain really grounded in our mission, which means to bring the best of European science to those who need it, from the regional level, the national level, and international level. Bringing the best of European science and technology to society is not something that is foreign to ECMWF. We have been doing it for 50 years. So actually, this year, 2025, we are celebrating our 50th anniversary. And we are going to continue to work hard using all the data, cutting-edge science and technology, together with the community, to deliver the best possible relevant information about climate change at the European level. So in summary, we've come a long way, but climate doesn't wait, and neither will we. So I would like to express my most sincere appreciation to the Spanish Minister of Science, the Councillor for Climate Improvement, for their leadership in advancing climate action. Also for the European Commission for their vital vision and support throughout this Copernicus adventure, and the whole community for being here with us and for dedication in this joint endeavor. Muchas gracias.
Thank you, Florence. We really appreciate your words. So next, we're happy to have Hugo Zunca from the European Commission. Hugo leads Copernicus services at the Commission Department of Defense, Industry and Space, and his vision has been essential in shaping the success of Copernicus. Hugo, over to you.
Thank you. So thank you very much. Good afternoon. Dear Minister Morand, Councillor Florence, dear colleagues. So it has been a couple of times already that I have been here in this GA to, to open this annual event, and it's a particular pleasure today to be here in Valencia, in this region, and this wonderful, wonderful city. It's nice as well because, for instance, Spanish institutes, companies bring quite an important contribution to the service, to the C3S, to Copernicus in general. So you are involved as well in the industrial contracts, activities for the satellites as well, which are all part of this overall Copernicus endeavor. So I'm happy to be invited again to witness the great progress you have done over the past year. Florence has just alluded to a couple of these aspects of the scientific and technical work which is behind the service. I would like to say that the Commission indeed values very much the cooperation of more than 10 years now on Copernicus climate change service. And well, I would maybe like to take the opportunity as well to thank you, Florence, for your contribution and your support over the past years on this. So maybe what is Copernicus? To frame this a bit, so the European Union has teamed up together with the European space agencies and a number of other key players in their respective thematic areas, such as ECMWF for numerical weather forecasts. And all together, we built with our partners the most complete and most sophisticated system for Earth observation and Earth monitoring in the world. So what is unique about Copernicus? Unique about Copernicus is a close integration of the Earth observation data, meaning the satellites we have owned and we own and which we are operating, together with the thematic services that turn this data into usable, actionable information. And so we call this, half joking sometimes, policy-ready products. No? So what this service is delivered should be ready to be understood by politicians, and they should be able to do something with it and to improve their work they are doing. Second aspect I would really like to underline very much is the important link all of our activities and as well the climate service have with research and innovation. So on one hand, the services and the Copernicus program as a whole, they deliver lots of output and interesting data for all science to advance the understanding of our world and the processes around it. But in return, we rely on the research program in order to feed and to evolve our services to keep them relevant and to keep them at the cutting edge of technology and innovation. Coming now a bit to the climate change service, we have heard this as well a bit in the previous interventions by Councillor and Florence already, that despite all the other urgencies we have today at the global stage, if you look around there, so we can still say that climate change remains one of the most fundamental challenges for humankind over the next decades. And so the climate change service, Copernicus Climate Change Service, produces indeed the European State of the Climate, the reanalysis we heard about. And all this allows us to describe and to analyze the past climate and to basically see in quite some detail what's going on. So we have hotter, drier seasons. We have hit the 1.5 degrees ceiling last year. And I think WMO published a report some days ago where they say there's quite probable that we will touch the 2.0 degree in the coming years. So, and as well, we see that, for instance, the CO2 concentrations in the atmosphere still climb and so far do not go down. But that's only one part of the coin, to monitor the atmosphere, to monitor what the climate is doing. At the same time, specific sectoral or regional analysis, the climate risk analysis, which is important that we try to assess what could happen or what is threatening our livelihood due to climate change. Only these climate predictions allow us to prepare our own society and policies in order to cope with the climate change to come, which is partly already here and still expected. Again, for this climate adaptation aspects, again, the aspect that these products of the service are really ready to use and ready to be interpreted into concrete adaptation planning measures is really important. Councillor, you have referred to the extreme events. Clearly, I don't need to remind anyone here in this area on the toll in death and in particular as well the economic damage linked to extreme events. So my own country has been hit in 2021 as well, quite severely. And any information product that can improve, for instance, the prevention, the preparedness to such extreme events, or support as well the operational capacities on the ground that help and recover people, all that is money very well spent and can help to save life and goods. And I think that's an aspect which we should not forget in total. So again, what we see today as a climate change service, what we witnessed today with the 8th General Assembly, has been built indeed not more than 10 years. So there has been a very rapid development. So this member of the Copernicus family was forced to grow up pretty fast in a way. And we started building on a couple of research projects, and it has now grown into a very significant operational capacity. And it has become a reference, for instance, for UN, for IPCC, for UNFCCC, WMO, and the like. And I think we can all be proud of what you have achieved here with this service. And clearly the journey is not yet over, so I think unfortunately it will be still some time before the service is going to be obsolete. And so I thank you for your attention. Thank you very much.
Thank you very much for your words, Hugo. And to close this opening session, it's a pleasure to have the Spanish Minister of Science, Innovation and Universities, Diana Morant, in a city that you well know. Diana, over to you.
Directora del Centro Europeo de Previsiones Meteorológicas, directora general del Ministerio de Planificación, Coordinación y Transferencia del Conocimiento, concejal de Mejora Climática del Ayuntamiento de Valencia, responsable de Copernicus en la Dirección General de Industria, Defensa y Espacio de la Comisión Europea, director del Servicio de Cambio Climático de Copernicus, representantes de las agencias meteorológicas, empresas e instituciones europeas, investigadores e investigadoras, medios de comunicación, señoras y señores. Good morning and welcome to Spain, a country that embraces science and innovation like never before. With a government that is investing in and trusting more than ever in our most transformative asset, scientific and innovative talent, very well represented in this room. This historic commitment to research, development and innovation is working. It is already helping Spain become a strong engine of economic growth and quality job creation in Europe, and we are doing it without taking away people's rights to create wealth. Este compromiso firme con la ciencia y la innovación, alineado e impulsado por la Unión Europea, ya nos está ayudando a ganar competitividad y autonomía estratégica. Y también a proteger lo que hoy nos define como el continente más civilizado del mundo y donde mejor pueden vivir las personas con independencia de su género, su origen, sus rentas o su forma de amar. Nuestro estado de bienestar, nuestra principal fortaleza, que se asienta en unos valores democráticos innegociables. Señoras y señores, permítanme que entre en materia recordando un famoso documental norteamericano que hace 20 años sacudió la conciencia de mucha gente. Se titulaba Una verdad incómoda y hablaba del cambio climático, vaticinando ya sus devastadoras consecuencias. Tragedias como la que sufrimos especialmente aquí en Valencia, en mi tierra, hace justo 7 meses. El pasado 29 de octubre, una fatal dana acabó con la vida de 228 personas, arrasó 75 municipios, causó daños valorados en miles y miles de millones de euros y un dolor que nunca olvidaremos. Y el origen fue el cambio climático, una verdad que mata y que se ceba especialmente en el Mediterráneo, aumentando la frecuencia y la virulencia de catástrofes naturales como la que vivimos aquel 29 de octubre. Nos enfrentamos a nuevos patrones climáticos que están poniendo a prueba la capacidad de respuesta de administraciones y de servicios públicos. Esa es la verdad del cambio climático, una evidencia científica que hoy algunos niegan desde las instituciones, políticos de algunos países de los más poderosos del mundo, abogando por romper, por ejemplo, con el Pacto Verde Europeo o con el Acuerdo de París, nuestros compromisos por alcanzar la neutralidad climática en un alarde de irresponsabilidad que pone en peligro a las personas y al planeta. Voy a dar un dato. En España podríamos pasar de las 428 olas de calor al año de ahora a superar las 2.200 olas de calor anuales entre los años 2051 y 2100. Es decir, si no actuamos, estas olas se multiplicarán por 5 y la mortalidad atribuible a esas olas pasaría de las 1.300 muertes al año de ahora a cerca de 13.000. Son datos procedentes de la Guía Aclimatarnos realizada por el Instituto de Salud Carlos III, nuestra mayor institución pública de investigación biomédica, investigación pública de España. Una vez más, la ciencia diagnostica, anticipa y avisa. Y el Gobierno de España escuchamos, como nunca, ese conocimiento para tomar decisiones y orientar nuestras políticas públicas centradas en el bienestar de las personas. El Gobierno de España, el Gobierno del presidente Pedro Sánchez, ni ignora la emergencia climática ni mira hacia otro lado. Al contrario, encaramos el desafío con firmeza, porque estamos al servicio de la sociedad. Y quiero dar otro dato. Casi el 80% de la sociedad española considera que el cambio climático es un problema muy grave. Lo indica el estudio que ha realizado la Fundación Española para la Ciencia y la Tecnología. El 80% de nuestros vecinos y vecinas. Porque ellos, los ciudadanos, están del lado de la ciencia, la principal línea de defensa ante el nuevo escenario de emergencia climática. Con esa visión, España participa, apoya y seguirá apoyando el programa europeo Copernicus, como llevamos haciendo desde hace 2 décadas, también a través de la Agencia Espacial Europea, que es la responsable del desarrollo de los sistemas satelitales. Los satélites de observación terrestre Copernicus son una tecnología que nos ayuda a percibir y entender nuestro entorno con muchísima precisión. Copernicus nos brinda conocimiento esencial para diseñar las políticas del siglo XXI, las que hacen avanzar la transición energética, las que garantizan la seguridad alimentaria, una gestión del agua eficiente y una nueva planificación urbana más resiliente. Las que nos ayudan a prevenir, anticiparnos y reaccionar ante los riesgos y catástrofes naturales. Por ejemplo, durante la emergencia de la Dana, los satélites de Copernicus facilitaron la obtención y análisis de imágenes de las zonas afectadas durante las 24 horas del día. Una información primordial para guiar con rigor los servicios de emergencia y mitigar el impacto de la catástrofe. O, por ejemplo, en la erupción que tuvimos en el volcán de La Palma, gracias a Copernicus, nuestros científicos supieron prever con horas de resolución y metros cuándo y dónde iba a erupcionar el volcán, gracias a la observación de la deformación de la superficie de la Tierra de Copernicus. Y eso hizo que se tomaran decisiones como la evacuación de poblaciones y no tuviéramos que lamentar la pérdida de ninguna víctima humana gracias a la ciencia. Por todo esto, para nosotros es un honor recibiros hoy en Valencia, en España. Dar la bienvenida también al Servicio de Cambio Climático de Copernicus, que es mucho más que una herramienta útil para los responsables públicos. Es un servicio con propósito, el de contribuir a la construcción de sociedades preparadas y resilientes ante los efectos del cambio climático, uno de nuestros principales desafíos colectivos. Con esa misma misión, el Gobierno de España ha puesto todas las capacidades científicas y técnicas del país al servicio de la reconstrucción de los municipios afectados por la Dana, con iniciativas pioneras como programas de innovación para la resiliencia climática y agendas urbanas de reconstrucción. Tenemos que salir mejor de esta crisis de lo que estábamos, mejor preparados de lo que estábamos antes de la crisis. Un modelo ejemplar de reconstrucción transformadora, donde toda la potencia científica y tecnológica de las instituciones estatales de ciencia e innovación, junto con las universidades públicas, está trabajando en un modelo de red de cooperación municipal liderado por los ayuntamientos, que son quienes mejor conocen el territorio y las necesidades reales de la ciudadanía, conectando la ciencia con la ciudadanía, la ciencia con las necesidades concretas de cada pueblo o ciudad. Porque no nos cabe ninguna duda, la mejor versión del futuro pasará por la ciencia y pasará también por el espacio, un escenario desde donde también estamos transformando todo el territorio y la sociedad. En España tenemos un proyecto estratégico de país en el sector aeroespacial. Es la mayor apuesta público-privada de nuestra historia en el sector aeronáutico y del espacio. Hemos movilizado ya 2.800 millones de euros de inversión pública y pretendemos que también se traccionen otros 4.500 millones de euros también de la iniciativa privada. Hemos creado la Agencia Espacial Española, ya tenemos voz propia en la carrera espacial. La impulsamos en nuestro país y también en Europa, apoyando programas y empresas punteras que nos están posicionando a la vanguardia de la industria espacial. Nombrar una empresa que está deslumbrando a toda Europa y al mundo con ese cohete que lanzaron en noviembre del año 2023, el Miura 1, que es la antesala del Miura 5, que muy probablemente se va a convertir en el primer lanzador de microsatélites de toda Europa, con tecnología 100% europea, de una empresa valenciana, de Elche, PLD Space. También estamos desarrollando y queremos lanzar al espacio una constelación de 16 satélites, la constelación atlántica, España y Portugal, que nos va a permitir nuestra capacidad de observación, teniendo muestras de la Tierra a una mayor frecuencia que solo con Copernicus. Un grandísimo aliado ante las emergencias, los incendios o las inundaciones. Y desde la industria española estamos liderando también por primera vez el desarrollo de una de las versiones mejoradas de los satélites Sentinel, concretamente el LSTM, que monitorizará la temperatura de la superficie terrestre a partir de 2028. Tecnologías españolas que nos capacitan para afrontar mejor los retos presentes y futuros. Y además, nuestra posición en Europa es clara. España quiere seguir siendo un actor clave en los grandes programas espaciales europeos y contribuir a que Europa recupere su liderazgo tanto en el lanzamiento como en la explotación de servicios espaciales. Y así lo hemos defendido recientemente también en Bruselas, en el Consejo de Competitividad Europeo. Queremos que el nuevo programa espacial de la Unión Europea refuerce un ecosistema competitivo de innovación espacial, que facilite el acceso de las pymes y startups, que fomente la atracción del talento cualificado y que potencie la colaboración entre las universidades, los centros de investigación y las empresas. En definitiva, queremos seguir ganándonos la confianza de la Unión Europea, del talento internacional y de las empresas más disruptivas del mundo, que ya saben que hoy somos un mejor país para la ciencia y la innovación. Un país que ha pasado de recortar a invertir como nunca en I+D+I, de expulsar a su talento a atraerlo, de participar solamente a liderar políticas europeas. Y juntos, con la integración de nuestras capacidades científicas y tecnológicas, ensancharemos el camino hacia la prosperidad compartida, con el impulso de una ciencia y una innovación abiertas que protegen a las personas y al planeta, como lo es Copernicus. Un programa que toma el nombre de un científico visionario que nos enseñó algo especialmente inspirador en este tiempo complejo, que observar el mundo con nuevos ojos puede cambiarlo. Sigamos observando la Tierra desde la perspectiva Copernicus, desde lo alto, para comprenderla mejor y para cuidarla mejor. Muchas gracias.
So I'm going to ask, please, for all the authorities to come here on the stage for a family picture. So Carlos, Florence, Diana, and Hugo. So, now let's welcome Carlo Buontempo, Director of the C3S at the European Center of Medium Range Weather Forecast. Carlo will give us an overview of the C3S program's highlights and what to expect from today's discussion. Carlo, over to you.
Buenas tardes, buona tarda, buon pomeriggio. Good afternoon, everyone. And clearly, I now have the stage and I can switch the tone and get really sciencey and have a presentation with a lot of PowerPoint that I will have 80 PowerPoint in the next 10 minutes. Not quite, not quite. First of all, I would like to thank the distinguished speaker who preceded me on this stage, the Spanish minister, the concejal, the climate improvement, which I think is an excellent job title, Hugo and Florence. The very fact that they have accepted our invitation, I think, is quite telling, and is telling of how much the Copernicus program has actually grown over the last 10 years. And also, I would like to thank all the previous speakers for their support and their very kind words. They mean a lot to me, and I think they mean a lot to all of us. We are very pleased to be here in Valencia, also because I think talking about climate in this location, you feel really in the climate here, is a pleasure. And I, once more, would like to thank the concejal, Carlos Mudina, for having us here in Valencia. As always, the General Assembly is an opportunity to come together as a community, and is a great pleasure to meet you all again, and to reflect on what we have achieved and chart a bit the course of what's coming for the next few months and years ahead. This will be one of the two goals of my introduction. The other one is to give you a bit of a yellow page. Well, they don't exist anymore, but a bit of an indication of a roadmap of what to expect on the next couple of days. The last year, we heard, has been in many ways exceptional, not only in terms of climate extremes that we have witnessed, especially here in Valencia, and we heard the consequences of the Dana and saddened by the outcome. But the problem is that actually this is not a one-off, it's not an event that happens out of the blue. This picture is a sentinel picture that comes from last week, and talks about these glaciers in the Swiss Alps that completely destroy the village of Blatten. This, for me, is an indication of the fact that these extremes, the one in Valencia, the flooding in Central Europe, and now these glaciers in the Alps, are here to stay. In every foreseeable future, we do expect the intensity of some of these events, or their frequency, to actually go up. And in a sense, this doesn't come as a full surprise. That's probably the number one question that they ask us when journalists interview us. Were you surprised by it? Well, unfortunately not. And in the specific instance of these glaciers, there were papers 20 years ago talking about the potential collapse of glaciers and the effect on landslides. As a society, we need to learn to trust our data, observation, information, and knowledge, as this is becoming essential to develop a truly climate-smart society. We decided to come to this city much before the tragic event of last October, but the backdrop of what has happened here is well connected to the topic of this GA, which, as you may know, is extreme events and climate adaptation. A theme that you will see emerging in different shapes and form throughout the next 3 days. Looking back at the last 12 months also means looking back at the scientific and operational work that this community has delivered. In the face of rising urgency of climate and the growing complexity of the socioeconomic world in which we operate, C3S has managed to continue in the provision of consistency, clarity, and trustworthy output. When we started this adventure, and I was discussing with Hugo a few days ago about the first General Assembly. I wasn't there. I think Dick was there with Jean-Noël and Bernard. the General Assembly was made of 4. So in those initial discussions, one of the key words was to become an authoritative voice on climate. Well, 10 years down the line, I think we have become that authoritative voice on climate. As Florence said, a milestone for the service year after year is the publication of European State of the Climate report. And I think it's much more than just a report. It's the data that is behind the report, and it's also the way the report is built and put together. And the graphics and the work that Anna's done on all the graphics and all the authors have done really make this shine. This year was preceded by the Global Climate Highlight in January, with a very large set of indicators supported by stunning visualization and a broader reach. The State of the Climate has become a key reference, not just for scientists and policymakers, but also for journalists, educators, and the public at large. Its resonance in the media, and again, Florence was mentioning the reach of the report, and its uptake across European institutions is a testament to the incredible effort behind it. In both cases, the European State of the Climate report and the Global Climate Highlight, this was the result of a joint effort and a great coordination, first and foremost with our colleagues of WMO, but also very much with National Met Services, research institutions, and many, many other players. This coordination is extremely important to us, and I'm pleased to have this afternoon also Zach Label from the US talking about his own experience in the US and how this is changing. So understanding about climate monitoring and the evolution of climate monitoring will be one of the highlights of today, and it will be quite prominent this afternoon. The public investment in C3S needs to be leveraged by a broadest possible community. We want to be sure that the data, information, and tools we make available publicly and freely can be reused so that others, many, many others, could build upon what we have done. Personally, I do feel that climate change represents the biggest challenge humanity has ever faced. And this should take precedence on any sort of personalism or localism or personal pride. It's really, we need to really work with the full community because we need the best mind, the best ideas, expertise to find a suitable way to confront this new challenge. Later today, we'll hear about the future of climate monitoring, reflecting on what has worked, what has gone well, and also looking into things that can be improved. But it's easy to think, and actually one of the elements that links directly to the theme of today is the fact that the European State of the Climate report contains in itself a summary of the most extreme events and how these have panned out throughout the years and what their distribution was over space. But it's easy to think that the program is made by the most visible output, and European State of the Climate report is clearly one of these very visible output. But as you know, there is much, much the bruise underneath the lid. I'm thinking, for instance, this is the scientist coming in, a very, very busy slide with a lot of color, right? But I'm thinking, for example, about ERA 6, and again, Florence mentioned ERA 6, the next generation of reanalysis. And I see the face of some of you, including Hans, being a bit perplexed because possibly I haven't picked the last scorecard of ERA 6. What I'm saying here is that this is not yet floating to the surface, ERA 6. We have just initiated now the preliminary start runs for this simulation, but there is a lot of work behind. And this single slide for me summarizes a lot of that work. It's a scorecard. If you're familiar with it, you know what it is. But effectively, it's a way of comparing a previous version of the model with the most recent version of the model. And this is done routinely in any numerical weather prediction center when you upgrade your model. And you look at different variables, you look at different regions, different levels, different forecast layer. And I won't have time to describe what's inside this single slide. It's enough to say that if it's blue, it's good. Right? And the fact that this is so stunning blue tells you a lot about the successes and the work that has gone into the next reanalysis. A lot is because the model has gone better, because the data simulation system has improved. But a lot of it is because actually we invested in the underpinning data, starting from in situ data. And in situ, and in general, all data, for me, represent really our climatic memory. And the climatic memory is something we should take care of. It doesn't stay there forever. It's at risk from many points of view. And we need to look at these old registers. This you see actually one page of a station book from Niamey airport, and it was a paper copy of it. Well, that paper copy is fragile, but if we digitize it and make it available, then this can have a massive impact on the quality of our reanalysis. This is exactly what we have done over the years, and you see that for some data streams, you look at, for instance, at humidity near the surface, this data rescue has provided a six-fold increase in the amount of information. So we will discuss about in situ in the next few days. We'll discuss about observation because they are fundamental. And it's not just the in situ part that matters, because we are, first and foremost, an Earth observation program. We rely very heavily on the satellite data coming from the Sentinel, coming from the other sensors, and we use them. Probably Florence will agree in saying that ECNWF is probably the biggest consumer of data coming from satellite. We are a great consumer of this data, and this data is providing the backbone for our reanalysis. But as you know, the satellite era started in '79, meaning that before '79, we didn't have the luxury of having this excellent snapshot of the planet. And so rescuing early data, early satellite data, as well as in situ data, actually can provide significant benefit to our effort. This is just one example. You will hear more about it tomorrow. This is an example of the archaeological work, if you want, for satellite data. It's a single instrument that flew on top of, well, in the early 70s. And this is basically 13 years after Sputnik, just to give you an idea of how old this information is, climate satellite-wise. And those you see there are typical coverage in terms of orbit over a day. Well, rescuing this data, making this data available, and assimilating this data into the model provide, again, massive improvement in our ability to describe the historical climate. Once more, complex plot, blue is good. This is different forecast time. Everything is blue, especially in the early forecast stage. So the reason why reanalysis looks so blue is because the model has improved, our data simulation scheme have improved, but also because we invested heavily in making all data available, reprocess all data, and use it in our models. We use the data coming from satellite also to provide a snapshot of the planet, looking at actually all the ECVs, the essential climate variable defined by GCAS. There will be a talk on Wednesday by Peter Thorne, who's leading the effort on rationalization of ECVs within GCAS and within WMO, to look at what the ECVs will look like in the future. But for now, we have this snapshot. And using this, this framework, we are trying to enlarge our ability to describe the climate. This, again, a very busy plot. These represent all 54 GCAS ECVs available now. Those you see in green are those for which now C3S can provide a climate data record for. And the different color represent others that are becoming available now in this phase of Copernicus, variable that may become available in the next phase of Copernicus, and variable for which reanalysis itself can provide valuable input. The overall goal is to have a snapshot of the planet for as many variables as practically possible by the end of this MFF or by the beginning of the next. As Florence said, the seasonal prediction, multi-system seasonal prediction of C3S, actually the ensemble has enlarged by the inclusion of the Bureau of Meteorology. The Bureau of Meteorology negotiation took the best part of 2 years, so I'm very pleased that in May our forecast joined, the forecast from the Bureau joined the multi-system. Unfortunately, we couldn't predict that it was going to be a relatively complex or dull month in terms of forecast. You see the ensemble at the moment, and it spans from a strong El Niño to a strong La Niña, centered around 0. So not much of a signal, but this couldn't be forecasted. What is true, as Florence already mentioned, is the fact that the strength of the multi-system depends also on the variety of systems that contribute to it, and having the Bureau on board is very important to us. On the climate projections, big effort has gone into the operationalization of the atlas. What you see here actually is extracted from the atlas that you can reach following the URL or scanning the QR code, extracting the projections in terms of temperature for the area surrounding Valencia. This doesn't require any knowledge, any coding, and is done by anyone who has a mobile phone or a computer and an internet connection. We picked up from where the IPCC left. Because of the IPCC process, the atlas needed to be frozen in time, and no additional data or functionalities could be added. We picked those and expanded to update both the data that flows into the atlas and the functionalities of it. We'll hear later today from one of the persons behind, I could say the father of the atlas, which is good because when you start talking about the grandfather, it means that you're getting old. So I would say the father of the atlas, followed by so that's Jose Manuel Gutierrez, and then the co-chair of Working Group 2 of the IPCC, Bart van den Herk, who will connect online. This is really important because our intention was to prepare the terrain for the IPCC to build upon what we have done in developing their own atlas for the next assessment report that is starting now. And you will hear about it later today. But actually, the program is so much more than the data that flows into it. It's about all the services, all the components, the user support, the documentation, the EQC, the training, and it really is difficult to summarize all of this in just one slide. But I want to single out the data store because the data store over the last year has gone through a massive change. It was at times a bit difficult and challenging, but we are today in a much better position than we were a year ago. And one of the bumps in this road was the fact that our counter of user had to be reset. So we went back to zero. From 320,000, we went back to zero. And in the space of a few months, we are already of 130 plus thousand and summing up. This is really significant, as is the volume of download that we have. So there will be more information about it. There is one element I want to stress here, because last year when we were at the General Assembly, there was a very strong feedback from you, a feedback of the fact that General Assembly should be more of an opportunity to talk to one another and less of an opportunity to have these plenary speeches and panel discussions. Well, we took you seriously, and so this year we actually organized the program to have plenty of space. The coffee break, as you have seen, are all an hour long. There are plenty of posters this year, more than 60 posters, divided in two turns. So there will be the first turn from today lunchtime till tomorrow, and the second from tomorrow lunchtime until Wednesday. And there will be plenty of stations where you can actually go and see the application, like Chiara has put together with the C3S team and the application teams, a lot of compelling application. There will be information about communication. There will be information about the data store. So please use those coffee break as an integral part of the conference, because that's really what they are. And EQC and all the rest are there too. I just will wrap up. There were not 80 slides, which I think you would be pleased to hear. I just want to say that over the next few days, we will dive deep into the data, into the strategy, into the ambition. And if we do it right, I think we'll may manage also to enjoy a bit the journey. So welcome to Valencia. Welcome to the General Assembly of C3S, a place where climate meets commitment, and in this case also meets a great view, and possibly later on also a very good paella. Thank you very much.
Thank you, Carlo, for your words. As you said, we need the best minds, ideas, and expertise to fight the climate change. So it is now time for our first thematic session, which is the role of climate in recent extremes. Let me announce that after the three presentations, we're going to have a coffee break right here in the corner. So as we move into this session, it is important to remember that the climate services are grounded in observations. With a robust data collection, it will be impossible to develop effective climate services. Our first speakers, Els van de Wessela and Gerard van der Schrier, will go into more detail on this. Els and Gerard, please take it away.
So thank you for inviting us to give us a talk here about the importance of in situ observations. So let's wait for the presentation to come up. So we give this presentation because the landscape of station observations in Europe is changing quite a lot in the recent years. So especially with the EU directive that has implemented last year, the new station observations are coming available. So what we will show is the current status of the observational data, and then we give you a short glimpse into the future. So this is a slide that gives an overview of 3 of the gridded in situ datasets which are available in the C3S. So the pan-European map shown here is from EOPS, and it's the precipitation from July 2000. And for the northern parts, we have the Nordic gridded climate dataset, which covers Fennoscandia. And for the Alpine region, we have the LabRec dataset. The EOPS dataset is a gridded dataset for 0.1 by 0.1 degree, which is about 10 by 10 kilometers. It has 8 variables and a daily resolution. And it's available from 1950 to now, and it is updated twice per year. For the Nordic gridded climate dataset, it has 1 by 1 kilometer resolution for Fennoscandia. It has temperature and precipitation, and it's only a daily resolution, and it's available from 1960 to now. And it's also updated twice per year. NGCD has also preliminary daily updates, while EOPS also have preliminary monthly updates, so you can have a faster gridded data set in between the full versions. LabRec is the 5 kilometer resolution and for precipitation only, but it's a monthly data set. The difference with this one is that it's based on a fixed station data set, so it's a homogeneous station density. And therefore, we have 2 different versions, one starting in 1871 and one starting in 1901, and it's updated every 2 years. So why do the in situ observations matter? So this is a plot from the State of the Climate Report from 2023, and on the left we have temperature, and on the right we have precipitation. And what you see here is a time series for the European land area, for both for EOPS and for the ERA5 dataset. And so therefore the in situ datasets are used as a comparison, but also as a ground truth for the state of the climate. And here we have a short analysis of the difference between in situ datasets and reanalysis. So on the left we have precipitation, and on the right we have the number of tropical nights. On the left, we see the 3 in situ data sets for EOPS and 2 different versions of the NGCD data sets, and ERA5 on the top right. What you can see here that the ERA5 has a much smoother overall view of this area, while the in situ data sets are more detailed in there. And if you look at the right-hand side, so you have the number of tropical nights, you can see that ERA5 is overestimating the number of tropical nights in certain areas for this specific summer and the specific areas in the north. So here we have a comparison for the Great and Alpine region, and it's a trend in precipitation for LabRec, ERA5, and 2 other in situ data sets. What you can see is that ERA5 has a larger trend in the northern part of this area, but also the 3 in situ data sets have quite some variations in this, and it might partly be due to changing that the station data underneath it is not homogeneous, while for LabRec it is. So also for extremes, additional data for a station can be quite important. So this is an example of the precipitation from July 2021 that has had a lot of flooding in the Netherlands, Belgium, and Germany. And on the left, we see the gridded data set, which is created by only using the synoptic stations. It's just the data that is shared fast between Met services, especially for the weather forecasts. And on the right-hand side, you see the gridded data set created with these synoptic stations, but also additional stations from the meteorological services. And although you can see that the area is the same between the two maps, but if you look at the extreme precipitation, I hope you can see it in the legend, the left-hand side goes to about 105 millimeters per day, while on the right-hand side it goes to 151. So especially the extremes are captured much better by the inclusion of more station data. So then we come to the station data set that is used for EOPS. This is the number of stations and the location of the stations in January 2010. So I just took one day to see which stations are available on there. And to note that it is a station of April last year. What you immediately can see is that the station density is not homogeneous over Europe. There are areas with much more stations and there are areas with less stations. And there are also different colors. For the green ones, we have the permission to share the daily data for non-commercial research and education, but for the red dots, we do not have them. But in some cases, it might be that the station data are available from the Met Service themselves, but they prefer to download the data from their own portal so they can keep track of the number of users instead of giving the data away through ECA&D, which is the underlying data set of EOPS. And also, this is the status from last year. And in the meantime, the EU directive has come into place, which has opened up access to a lot more station data sets. And especially the situation in Spain and in Italy has increased quite a lot since this plot was made. But the EU directive is only for the EU and the EUMETNet countries. And EOPS and the ECA&D data set, the European Climate Assessment and Data Set, is much broader than that. So there will still be areas and countries that are not in the EU and not in EUMETNet. So these areas might not open up the station area, and especially the southeastern part of Europe might be problematic and will stay problematic. So now I will hand over to my colleague to continue the presentation.
So clearly there's a reason why these Met services open up with their archives, and that is the push from the European Commission with its Open Data Directive. And as Elsa explained, it came into force last June, and there are specific themes for this Open Data Directive, and the high-value data sets are specified, for instance, for meteorology. And how EUMETNet has taken up this challenge is by making available data from these 5 pillars you see here on the slide. So observations relate to the weather observations, so high temporal resolution, short memory, but immediately available. And also climate observations are there, so a large historic perspective from a large set of data sets and a large station density. Weather alerts are there, radar data is there, and also the numerical weather prediction model data is there. And just to give you a flavor of how this is done and under what terms and conditions I've put up this table, these data are to be made available under an open data license, so in a much different situation than what we have seen in the past, say, a few years. Data will be in NetCDF, will be machine readable, and also the metadata will be available for these station data. So that will be quite a change in what we are seeing. And of course, making data available is one thing, but doing this in a uniform and harmonized way is another. And within EUMETNet, there is a project called Rodeo, which actually aims to harmonize this data access. And you see a bit of a graph over here. And what it does is that the user actually logs on to what is called MeteoGate, and it actually can access through the APIs the climate archives of all these Met services. At the moment, there are 9 of these MET services associated with this project, and we're trying to involve much more MET services by making available workshops which try to tease these MET services into making their data available through this platform as well. Interesting is that the open spaces in Europe, which are not covered yet, are covered by the data set which we also use for the EOPS. Interesting is that we have this red box in the center part, which is the climate aggregator. What it does, it adds climate data to the metadata of these stations, like trends or information on climate indices, so that science writers or interested science citizens can actually access this climatic information quite directly. And to give you a flavor of what's there, we have, of course, all the essential climate variables, and there are possibilities for MET services to add their own data sets. But it's not only the MET services which are interesting in terms of data provision. There are 2 examples here on the slide which are also interesting. One of those is the Armagh Observatory in Northern Ireland, which has records going back to the 18th century. And another one is a company in Portugal which has professional equipment on their vineyards, and they complement the network of the Portuguese MET service. And those are data we actually want to use as well and make available to society as well. And we're doing that by taking them one by one on and agreeing together with the European Environmental Agency on modifying the data license under which we can make these data available. And it's not only Europe and the present we are covering. We also tried together with the colleagues from Maynooth University trying to cover the globe. And what you see here on the slide is the coverage of sub-daily data the C3S has collected. On the right, what you see is the radio sound data we are collecting in C3S and showing, in this case, for the Lindenberg station, the difference with the Era 5. And as Carlo explained, we're also moving backwards in time by digitizing data together with the World Meteorological Organization. Well, to conclude this lecture a little bit, I would like to give you a bit of a perspective of what might happen as well. And there are also other data sets, not from the MET services, which are interesting. So we've seen this example from the SoGrape company, which is a so-called second-party data, so a professional organization, but a non-meteorological organization. But there are also large sources of third-party data, like crowdsourced data, which are available. And what you see here is a map of rain gauges made available through Netatmo. And on this map, you see tens of thousands of stations providing 5-minute precipitation. And some studies have already shown that actually adding this huge volume of data really improves the radar estimates, for instance, of precipitation over Europe. And we think that adding this type of data will clearly change the data landscape we are seeing in Europe at the moment. And just to give you a bit of an impression of what you can do with this crowdsourced data, I have one example from the Netherlands, from the country where I'm from. And what you see is a case study for a minimum temperature of a hot night, somewhere in September, I think it was. And on the left is a typical picture you would find on the website of our MET service. On the right, what you see is an estimate of the uncertainty by simple bootstrapping. And what you see is that the uncertainty is low around the weather stations and quite high actually in the interpolation. But by adding these crowdsourced data, and in this case we have about 800 of those stations from the WOW network, what you see is much more detail in the pattern. You also see cities lighting up, like in the Amsterdam region. The temperature is a little bit higher than in the surrounding regions. And also the uncertainty on the right side of the slide really becomes much lower, except in those 2 central regions in Europe, which are the forested regions. So the MET service doesn't have any measurements there, and there are not many people living there, so we don't have much data there. So the key here is to actually sample the landscape quite good. To conclude the presentation, our parent ministry finds these maps very interesting, not so much because of the added detail or because of the lower or the accuracy, but it's because of the engaging of citizens. That's why they find it interesting. And their argument is that it might help in restoring a little bit of this erosion of trust that is between the citizens and the state government. Thank you very much for your attention.
Thank you, Gerard. And thank you, Els. I want you to join me here on the stage to see if there's any questions online or our site. Maybe here in the audience. So it was all crystal clear. Thank you. So next we have Rebecca Emerson from the ECMWF. She's a leading expert on climate and health, having worked extensively on the European State of the Climate Report. Today she'll be talking about the growing importance of monitoring thermal stress. Rebecca, the floor is yours.
Good afternoon, everyone, and thank you for having me here today. As mentioned, some of you may already know me from working together on the European State of the Climate reports. So I guess while I'm waiting for the slides, this is my chance to thank everyone who contributed to this year's report, for those I haven't yet seen in person. But I also do other aspects of climate monitoring at ECMWF as part of the climate intelligence team. And one of my personal interests is in the links between climate and health, and in particular, the monitoring of extreme heat and heat stress, and how it is changing with time across Europe and the world. So the first question is, what is thermal stress? I think, as we know, there is a really close link between the environment and human well-being. Thermal stress refers to the negative impacts of the environment on the human body from these extreme thermal conditions, both hot and cold, and going beyond just temperature. So, for example, heat waves and cold spells are examples of those aspects of the weather and climate that are associated with increased morbidity and mortality, particularly in vulnerable population groups. And heat stress is actually the leading cause of weather-related deaths, and it really exacerbates underlying illnesses, for example, heart conditions, mental health issues, asthma, diabetes, and others. And heat stress and health impacts are really rarely a result of just temperature. You need to consider other aspects of the environment as well, such as the humidity, wind speed, the amount of sunshine, and others. So how can we monitor thermal stress in people? We use thermal comfort indices to do this, and the one that we're using at the moment is the Universal Thermal Climate Index, which represents a feels-like temperature. It has units of degrees C, which makes it quite an easily interpretable variable, considering how complex it can be, because it takes into account temperature, humidity, wind speed, the solar and thermal radiation, and also incorporates a model of how the human body reacts to different thermal conditions. And we can split the UTCI into 10 different categories of heat and cold stress, which represent different ranges of the feels-like temperature and how that could impact on the human body and the danger that the human might be in from the thermal environment. And we have an ERA5 dataset of UTCI that was published first in 2020, and it provides hourly global gridded UTCI from 1940 to near real time, the same as ERA5. And there are various other thermal comfort indices that are used around the globe, for example, in heat wave monitoring and communicating the dangers of heat waves at different national Met services and for different regions. The wet bulb globe temperature is quite a well-known one, humidex, the heat index. For cold, we have wind chill, but we're using the UTCI as really a very comprehensive variable that covers all of these different variables and how the human body responds. So I mentioned we can split UTCI into these various heat and cold stress categories, and a lot of our monitoring makes use of these particular categories, so I thought I'd just mention those here, where, for example, extreme heat stress, you're looking at anything above a feels-like temperature of about 46 degrees C, at which you're at extreme risk of, for example, heat exhaustion and heat stroke, which in the worst cases can be fatal. Very strong heat stress is anything over 38, strong over 32, and so on down to the very cold stress categories, where you've got very strong cold stress below -27, and extreme below -40, where you're looking at risks such as frostbite and hypothermia. So to monitor different aspects of thermal stress, we've been developing a range of different diagnostics, mostly based on this UTCI ERA 5 dataset. So we're looking at things like, for example, the number of heat and cold stress days that you might see per month, per season, and per year around the globe and across Europe. For example, producing maps, time series, and anomalies of all of those. We look at the daily maximum, particularly in terms of heat stress, the daily maximum feels like temperature, and how that varies across the globe with time and compared to the average. We also look at the area affected by heat stress on any given day. For example, what percentage of Europe is currently being affected by extreme heat stress? And we also sometimes produce event maps for significant heat wave events. And on the right is just an example of some of the data viz that we're producing for those. So how are we using these at C3S and EastNWF in our monitoring? The information from these heat stress diagnostics feeds into the European State of the Climate report, the Global Climate Highlights reports, various C3S articles that we write ad hoc, for example, during Europe's summer season. We're feeding it into the development of climate services, and we're supporting the work of other organisations, doing ongoing research and responding to media inquiries. And I'll just show a couple of examples of these over the next few slides. So it's difficult for me not to talk about the European State of the Climate report. So my first couple of examples are from the two most recent European State of the Climate reports, where we've been incorporating heat stress information for a while, but these I'm the most familiar with. So for the State of the Climate report covering 2023, we included this monitoring in the temperature and thermal stress chapter, and in the chapter that was kind of a spotlight section on the contrasting conditions that Europe saw during the summer in 2023. So in the map, on the animation on the left is showing the heat waves that occurred across a really widespread area of Europe during each month of June, July, August, and September in 2023, really showing how widespread heat impacts were across Europe, and that's based on a temperature-based definition of heat waves themselves. And then we take that one step further, and the map in the center shows the number of days during 2023 that were affected by very strong heat stress. So that's anything with a feels-like temperature above 38 degrees C. And you can see that in 2023, the most affected areas were, for example, southern Spain and Portugal, other parts of southern and southeastern and eastern Europe, with some areas seeing 50, even 60 days of very strong heat stress during the year. The bar chart on the top right is showing you how that category of heat stress is changing with time from 1950 to 2023, and you can see quite clearly that the number of days that Europe is seeing with very strong heat stress is increasing with time. And then the chart on the bottom right is a statistic we looked at for Southern Europe for 2023, which was, as you can see, particularly affected by heat stress, and it showed that on a particular day in July, 41% of Southern Europe was affected on one day at the peak of a heat wave by very strong heat stress. So moving on to the latest European State of the Climate report, which was just published recently in April. We moved and included even more thermal stress monitoring. So these are two screenshots from the graphics gallery that we introduced for this year's State of the Climate report. On the left is the thermal stress section. We were doing enough monitoring on it that we gave it its own chapter this year, so all of those graphics are related to heat and cold stress. And on the right-hand side is the spotlight section that we wrote on the extreme heat and drought that impacted southeastern Europe last summer. And the ones I've highlighted there are those that are related to heat stress monitoring. So to give you an example, this is the number of days. I can't read the one down there with my contacts in, so I have to keep turning around. This is the number of days with at least strong heat stress, so it feels like temperature exceeding 32 degrees C during 2024 on the left-hand side. And you can see again the areas with the largest number of strong heat stress days, southern Spain, southern and southeastern Europe, but really in particular in 2024 it was southeastern Europe that saw a much larger than average number of days with heat stress. And Elsa already mentioned tropical nights. This is a new variable that we introduced to the State of the Climate Report monitoring this year. It was really a big part of the narrative that we heard about people's experience of summer last year. And it's a really important variable to consider also for the impacts on health. Because if the temperature doesn't drop at night, you really don't get a respite from that maximum heat stress during the day. So tropical nights are those where the temperature doesn't drop below 20 degrees C. And using ERA 5 and EOBS, we're also now monitoring the number of tropical nights across Europe. And the map on the left shows the number of tropical nights that we saw last year, and on the right, the anomaly in the number of tropical nights, showing again across large parts of southern Europe an above average number of tropical nights during the year. And the chart here is again showing how all of these different variables are changing with time. So 3 different categories of heat stress: strong, very strong, and extreme, and tropical nights on the bottom right. And this is part of the research I'm doing at the moment into how heat stress is changing with time. And you can see very clearly from all of these have been increasing significantly, particularly since the 1980s, with 2024 seeing the second highest number of all of these different categories of heat stress. And here I'm just showing an animation. I mentioned we had a spotlight section on the extreme heat that occurred during southeastern Europe last year. In contrast to the year before, where a really widespread area of Europe was affected by heat waves, in 2024, this was really focused a lot in southeastern Europe, where you can see from the timeline along the bottom, 43 of the 97 days from the 1st of June to the 5th of September saw heat waves, with the region's longest heat wave on record at 13 consecutive days with heat wave conditions, and at times as few as 3 days between the heat waves. And then the time series that are shown on the right there, at the top is the number of heat stress days, and at the bottom is the EOBS tropical nights from Elsa. And you can see that both of those in 2024 for southeastern Europe were completely record-breaking by a very large margin, so really extreme heat and a very long duration of extreme heat in the region last year. And I've also shown here a couple of ad hoc maps that my colleague Julian created for specific heatwave events that we received media inquiries about from around the world. So these are showing the feels-like temperature that was experienced in these regions during the heat waves, and then the category of heat stress that corresponds to. So this is part of the monitoring that we're able to produce when there's a particularly significant heat wave event or something that we get questions about. And then the last aspect I wanted to talk about is how we're incorporating these heat stress diagnostics into our climate services development. So I wanted to highlight the Thermal Trace app with a big thank you to all of my colleagues listed here for the collaboration on this. Matt, Anna, Chiara, Chris, James, thank you for all of your work developing this app. So Thermal Trace is an interactive app for exploring heat and cold stress worldwide. It should be accessible to anyone with an internet connection to log in and have a look at how extreme heat stress is and has been, and how it is changing with time across the globe. So here I'm just showing a sneak preview of the first beta version of the app, where you log in and you're able to see the feels-like temperature across the globe or a region of interest. You can change the interface to look at a range of different heat or cold stress variables, depending on what you're interested in. For example, the number of days with different categories of heat stress. You can change the time period, for example, to look at a recent heat wave in a region of interest, or the day you were born, or any other particular date of interest. And there's a range of other features. So, for example, showing here one of our time series features for the location of interest, which you can search for by clicking on the map or searching for the name of a place. Here you're comparing the feels-like temperature with the actual temperature to see how different those were for a certain period of time at a certain location, in this case Valencia, which had its first day of extreme heat stress in July 2023, according to this app. So to find out more about Thermal Trace and to see some of the other features, which I haven't had time to showcase here today, and hear about what else we're developing for the app, come along to the demo booths. I'm not sure which coffee break, tomorrow or Wednesday. Please do come along to the demo booths to try out the beta version, to give us any feedback on our first version of this app. And of course, there are other very interesting apps also in the demo booths, which you should check out, but really excited to be able to show you the developments for this app at the C3S GA this year, considering some of the initial ideas for this app really came from collaborations that we developed at the C3S GA, for example, based on work that UNICEF were doing, looking at how heat stress is changing with time and how that is affecting children across the globe. So that's really been the inspiration, and it's really nice to see that coming to life as a new climate service. So I will leave it at that. Thank you very much.
Thank you, Rebecca. Really interesting. Let's see if anyone has any questions. Yeah. There's anyone with microphone here? Okay.
Thank you very sorry. Thank you very much for this nice presentation. So when showing the time series of the Europe, I thought the average European tropical nights, it seems as if there's a decrease in the early years, so from 1950 to about 1960, and then an increase. Do you have any idea why this happened, or is it just chance?
You're right, I have also looked at maps of that, and there are parts of Europe where there was a slightly decreasing trend in tropical nights and in heat stress. It's part of my research to look into why, but I haven't quite got an answer for you yet. So once I get round to working on that, now that the State of the Climate's published, I hope to get an answer to you soon.
Thank you, Rebecca, for an excellent presentation. My question was on the indices, because all the indices you presented are about instantaneous value, and I was wondering whether, well, I know that Chiara and others are looking at indices that contain some sort of a memory on the cooling at night, and I was wondering whether there is any plan of using those and looking at those in the future.
Yeah, so we've discussed other indices that are available that incorporate this kind of thing. At the moment, we have this fantastic ERA 5 data set, which we're hoping with ERA 6 and others might be expanded out to other thermal stress indices, and I'd love to be able to explore whether we can expand the app to those then, but at the moment we've been focused on the one that we have a long time series available, but there's opportunity to further explore others.
Is there any online questions? Carlo? Okay. Yeah, we have another one. Okay.
Thanks. The heat app looks very interesting. Is it developed in response to particular user needs, or do you have a particular user in mind?
So as I mentioned, some of this came out of work that we did in collaboration with UNICEF, providing some post-process data in response to an answer of a question of how is heat stress changing around the globe and how is that affecting populations. We've had other similar questions, for example, from the media, from other scientists. So we're trying to target quite a wide range of, quite a wide audience with this app, but we're really thinking that the most likely users are probably going to be, for example, other scientists interested in the interface between climate and health and extreme event monitoring, the interested public and journalists are kind of the main audience that we're trying to target. Quite wide.
Okay, so thank you.
Thank you.
So following Rebecca, we have Amy Watterson from the UK Met Office. She will explain how attribution science can help local decision makers better understand extreme weather events. So please, Amy, take it away.
Good afternoon, everyone. Thank you for the invitation. Thank you for the invitation to be here today. My name is Amy Watson. I'm a climate services scientist. Thank you. I'll start again. So, hi everyone, my name is Amy Watson. I'm a climate services scientist at the UK Met Office, and together with colleagues, we've been looking at the use of attribution science for different decision-making communities. And this is a project under the Met Office Hadley Centre Climate Programme, which is one of the key programmes of climate science research that we deliver to UK government. So firstly, what is attribution science? Well, it allows us to quantify the influence of different drivers on extreme weather events, including the role of human-caused climate change. And over the last couple of decades, this has generated a real wealth of evidence that's shown the link between human activity and an increased intensity and frequency of extremes around the world, as we can see from images here, and as mentioned by the earlier speakers. And the strength of this evidence has been continuing to grow, as we've seen in successive IPCC reports. It's also emerged as this really powerful scientific tool with which we can connect people's present day and often, unfortunately, disastrous experiences of extreme weather with longer-term climate change, which is sometimes challenging to see. So a number of different extreme event attribution methods have emerged. While I don't have time to explore these in detail today, this slide is showing you that different methods are able to provide different types of information about extreme weather events. So the utility of these is very much dependent on the needs of the users, what are their key questions of interest. So this is just to highlight that there isn't a one size that fits all in terms of using attribution science. So the advances we've seen in this field, coupled with a kind of increasing demand for rapid attribution studies around the time of an extreme event occurring, is leading some regions and countries to develop operational attribution services. And so these deliver these kinds of assessments soon after an event has occurred. So C3S has just started a contract to deliver an operational extreme event monitoring and attribution service. This is going to be co-led by UK Met Office and KNMI. It's going to be built around the key activities you can see in the figure here. And you can find out more details of this during the poster sessions tomorrow and Wednesday, presented by Mark McCarthy. So back to this project, the questions we've been exploring here are: what are the policy or decision-making contexts in which attribution science is being applied or could be applied? What are the constraints to this? And also, how does attribution science fit in with other lines of evidence? And in terms of the use cases we've been looking at, these span a range of response timescales, and these are communication and awareness raising, disaster risk management and humanitarian response, climate adaptation, losses and damages, and legal challenge. And as you can see, these cover a really broad range of topics, disciplines, so there's absolutely a need for transdisciplinary working across science, policy and practitioner communities to really understand the context in which science might be applied and where the key questions of interest are for these different communities. We've been doing this by diving into the literature, so using attribution science is relatively new, so we've been looking closely at the literature and combining this with our own experiences of working with some of these communities. So I'll now walk through some of the key questions of interest that we've identified for a number of these different use cases. So, did human-caused climate change influence this extreme event? This has been particularly of relevance to the international dialogue around losses and damages under the UNFCCC. experts have highlighted, however, that the issues around equitable access to attribution, so not being able to perform an attribution assessment for all events and in all regions, is a limitation in this area, and so an individual attribution assessment shouldn't be a prerequisite for access to finance. Which drivers contributed to an extreme event? So being able to isolate specific drivers of hazards, say for example using a climate storylines approach, so understanding what drivers led to an extreme rainfall event and flooding. This can improve our ability to model such extremes, and this can in turn feed into forecasting systems for early warning. And this is particularly important in the disaster risk management and humanitarian use case in terms of extending lead times for humanitarian response. Is this the new normal that people need to prepare for? So the ability of probability-based attribution methods to assess the likelihood and magnitude of extremes gives us this really strong line of evidence around how climate change is affecting the extremes we're experiencing now, how that hazard component of the risk envelope is changing. And we can combine this with information from climate projections to give us a sense of how these types of events might change in the future. And this is extremely crucial if you're thinking about which adaptation or disaster risk reduction options to prioritize. And lastly, one of the emerging areas of application of attribution has been this idea of using it to assess the effectiveness of adaptation interventions. So comparing scenarios with and without a particular adaptation intervention to see what that means for the impacts of an extreme event. So in the last half of this talk, I'll just walk you through in a bit more detail what we've been synthesizing for this particular use case around disaster risk management and humanitarian response. So this is really just to give you an idea of the way in which we're synthesizing this information, and the idea is to try and make it as accessible as possible to both the scientific community and then also to policy and practitioners who may be interested in applying this science. So firstly, important to understand the operating context of this area. So disaster risk management and humanitarian response is very much focused on mobilizing international assistance to disasters, and then the risk reduction component is focused more on the longer term preventative measures and resilience building, of which weather and climate is part of that. So what are the opportunities for attribution within this use case? So firstly, planning. So the ability of attribution science to tell us about the non-stationarity of hazards. So is the risk of flooding in a region changing? And also what does that mean for the exposure of different communities within a location? This can be really, really important in terms of planning, in terms of where to position resources or resources for this sector. And then thinking about the drivers of extreme weather and impacts, the emerging field of impact attribution offers us this really exciting potential to look at the non-climate drivers of extreme weather events. So bringing in the role of, as well as the meteorological hazard, human response to the event itself, exposure and vulnerability, to understand how these might all intersect to connect with the impacts that arise. And this ability, or this potential ability to generate this holistic understanding of what has contributed to the impacts of an extreme weather event is really powerful for this use case, which is focused on understanding the greatest levers for risk reduction. And then, the last example I have here is disaster risk finance. So a number of mechanisms exist that are trigger-based, and the idea is that these can provide sort of timely and accessible finance to support the the recovery in the event of a disaster. One example of these is parametric insurance. This is a growing area, and the premiums that are set within this are usually focused on risk over the near term, so the kind of next 5-year period. So the ability of attribution science to tell us about the likelihood of extremes in the current climate is clearly really relevant to this aspect. It's also worth noting the value of combining information from future climate projections here to ensure that this area is also thinking longer term and not kind of supporting any sort of maladaptive actions. And then there's, as many of you will be aware, there's a number of quite significant constraints to some of these applications I'm talking about here. So the ability to actually causally relate extreme weather and impacts remains challenging. There's often many drivers involved, and so it's not a simple task. Being able to capture the scale at which impacts occur in sometimes coarser climate models can be challenging. And there's often a limited amount of data on impacts, losses and damages that occur from extreme weather, and that's very variable in different parts of the world. It's worth noting for this use case, being able to differentiate that data to account for socioeconomic and cultural factors is really kind of crucial if any efforts to strengthen future resilience are being kind of targeted in an effective way. So what we're saying here is that attribution science offers an additional tool alongside other lines of evidence to support this use case. And those other lines of evidence include impact and risk models, climate projections, which all can kind of feed into this complex assessment of climate risk. And then the last part I'd like to focus on today is this slide here, which shows us that the potential for and application of attribution science is uneven globally. So this map is produced by Carbon Brief, and it shows the distribution of where attribution assessments have been produced for different parts of the world, so for extreme events in different parts of the world. And you can see there's much fewer studies in the global south, and this isn't a reflection of the fact that there's less extremes in these parts of the world, or indeed lower levels of vulnerability and exposure. It's in part due to a combination of observational data limitations, modelling capability, and also the kind of the capacity in country to deliver attribution assessments, particularly around the time of an extreme event. So there are efforts underway to address this challenge. There's much more effort that's needed if we're going to be able to answer some of those key questions I brought up earlier, which are really key to kind of building near-term and longer-term climate resilience in all parts of the world. Okay, so I'll just finish up with a summary and some ideas for where this might go next. So hopefully I've given you a flavour of how attribution science has the potential to be an additional line of evidence alongside others to inform some of these policy and decision-making use cases. There's benefits and challenges to this, and there's a need for transdisciplinary working to advance some of these research areas. And within that, this need to address equitable access to this area of science, the observational data limitations, and crucially, a strengthened policy practitioner and climate literacy across those fields to progress this further. So I'll finish there. Thanks so much for listening.
Thank you, Amy. Let's see if anyone has any question here, on site or online. Not online. Not on site. Here, yeah, we got one.
Hi, I was at EGU this year and I saw a presentation on somebody using AI for rapid attribution analysis, and they claimed in unpublished work that they could match world weather attributions results using far less of the computational power and data. So I'm just wondering how you see that in relation to this project.
Thank you for the question. Yeah, I absolutely think that's got a key role to play here. It's not quite an answer to your question, but one of the methods I had up was some experts have suggested the idea of using existing evidence around the time of an extreme event if the desire is for a statement that's something like, did climate change influence this type of event? So yeah, I think there's potential for that AI and machine learning to come in to synthesize the information we already have, and I'm sure in many of the other methods as well. But yeah, I'll defer that to attribution experts to answer that. Yeah.
Anyone else? Yeah.
Yeah, thank you very much for this very nice presentation. I'm thinking about the success of these attribution studies is crucially dependent on the quality of the data beyond. So what do you do to ensure that you get the best data, or also you can also only describe extreme events if you have the data. Neither you do it with models or with AI, it doesn't, but you need the data. What do you do?
Yep, thank you for making that really crucial point. I guess it's, in some senses, a real benefit of the methodology because you need robust data to kind of produce the assessments. That gives us more confidence in the assessments that we can produce. But that also, yeah, just to agree, really, that was my point with the final slide, is that in some parts of the world, it's really challenging to produce these assessments. And so if we're going to use this type of science, and it goes beyond attribution science, climate science more generally in decision making, there's a real need to address those discrepancies in the observational data and so forth. Yeah, if we're going to do that. So I don't have an answer to your question, but just yeah, agreeing that that's critical.
Anyone else? Thank you, Amy.
Thanks so much.
And thank you all really for being mindful with the time. It's really important. So now we have a coffee break. It's going to be right here in the corner. As Carlos said, it can be really interesting, so please take advantage of it. But please, we kindly ask you, everyone, to be back in the room at 5, okay? Enjoy it. Okay, so welcome back. I hope you enjoy and had a chance to recharge. Remember that always when we have a coffee break, there's going to be a poster session right here in the reception and demos on the terrace. So I encourage you all to visit them, of course. So in this session, we'll explore both recent trends and future projections. First, we'll hear from Zach Leib, a climate scientist who works at NOAA, on climate monitoring in the US. We're all hearing from you, from Valencia. Zach.
Hello, I will share my slides. Hopefully you can all see them. Does that look okay? All right, well, I will begin, and thank you so much for having me today. I'm sorry I couldn't be there with you, but really excited today to talk about a couple different things mostly about climate monitoring, but particularly data visualization and how we can use visualization to tell climate change stories. And I like to give all my presentations kind of starting with this example. So what you're looking at is you're looking at tiny little maps of the Arctic, and there's intentionally no labels here because I want you to just take a look at this graphic and absorb what types of patterns you're seeing. What are the colors showing? And so then usually I then start adding some labels. So in this case, you're looking at temperature anomalies. So anywhere, of course, in red is warmer than average and blue is colder than average. And I think visualizing data, in these types of different creative ways can really be a powerful way of storytelling. And in this case, it really shows a great example of the rapid warming we're seeing across the Arctic, along with that year-to-year variability, getting at the climate variability versus climate change angle. And this is really important because we know that climate change is happening in real time. Extreme events are happening all throughout the year. And my original background is in meteorology. So a lot of my friends are on TV meteorologists and, every night they're talking about the weather. And I think it's really informed my perspective on how I think we should be talking about climate instead of just publishing, once a year reports, but how can we talk about climate change in real time? And to me, this is really an opportunity to share stories. So one aspect of this is that I got very interested in pursuing this way of thinking about climate in data visualization by talking about sea ice. So often in the Arctic, sea ice grows during winter and shrinks during the summertime. But so mostly we would see articles published twice a year at the maximum extent of ice and the minimum extent of ice. But we know that extreme events are happening all throughout the year. So I figured, why only talk about sea ice during these extremes times a year instead of talking about it throughout the year? And here's one example. You're looking at a map on the right-hand side in the northern Pacific Ocean. On the right is Alaska, on the left is Russia, and that is the Bering Sea region. And this was an extreme event in 2018 where we actually saw a retreat of ice during the month of February, directly impacting communities all along the coastlines, preventing supplies from getting into these communities for airstrips where there would normally be sea ice, but it was left of open ocean water. And so I like, reflecting on my presentation, I want to keep, the key point of thinking about how data visualization, in addition to being a wonderful resource for scientists and for stakeholders, but it's also powerful for storytelling, for communication to non-experts and to the public. And a challenge we have in talking about climate, in real time, is that there's a lot of variability in the climate system. It's a big signal to noise problem. How do we disentangle when we talk about extreme events, sort of the climate change angle? And I think, there's been so much exciting work. We heard a little bit about it today about real-time attribution systems that are growing. And I'll share a few examples of that also. And, in the climate model world where we can, run experiments, this is much easier to talk about sort of the range of variability and the expected climate change angle. One aspect we use is like climate model large ensembles. So I think there's been a lot of exciting work when we think about observation data and monitoring these in real time. How can we try to communicate and assess with different types of metrics this angle of climate change and climate variability when we think about extreme events? And so I'll give you one challenge we experience in the United States for this climate variability versus change angle. So what you're looking at is trends in temperatures during the warm summertime, warm season in the Northern Hemisphere. So you can see, of course, over land areas, most areas are warming. But I want to draw your attention to this sort of, we call it a warming hole across the central United States, where there hasn't been, as significant amount of warming during the summertime. And this has been quite a challenging problem because when we're communicating to U.S. audiences about, increasing threats for summertime heat, we always have this challenge of describing this warming hole where there's actually been a lack of daytime warming. And particularly if we look at the historical record, and I'll show a graph in an example, some of the most severe summertime heat in the United States was actually back during the 1930s. This was a period called the Dust Bowl, where there was significant drought and really record-breaking heat across the central portions of the United States. So here's a newspaper article describing one of those dust storms. And if you've ever read the book Grapes of Wrath, this is very much about the types of challenges that were faced from the Dust Bowl era across the central United States. Here's an image of one of those dust storms that rolled across the Great Plains. This was very much a land, atmosphere, ocean type feedback for the causes of this, but it had major consequences, and it still is one of the most severe in our historical records. So here's a graph of showing what those temperatures look like across the summertime in the United States. The dashed white line is observations, and the red is from a climate model called SPEAR from NOAA's GFDL. So you can see, if you actually look at that dashed white line of observations, you can see on the left, there's that sort of peak in the 1930s, but you'll notice that there's kind of been a lack of a clear trend on the right-hand side. Again, getting to this point that despite we know that heat risks are increasing with global climate change, but communicating this and talking about this in the context of the historical record has been quite challenging. And so, I just wanted to annotate some examples of features we can see on this record. So you can see that only up until recent years have we experienced average summertime temperatures as warm as the Dust Bowl period. And so one way I've tried to, describe this type of variability to non-experts is through visualization. So here's showing lots and lots of little maps of summertime temperature anomalies in the United States. And as you saw, I showed an example of this for the Arctic as my opening figure, but you can see for the Dust Bowl period that, there isn't that clear sort of long-term warming trend. So this has been a challenge to really describe for research and for communications. And so one effort that was started at NOAA that I was a part of was developing our own sort of form of rapid attribution in the United States. So this was a NOAA team across many different laboratories and organizations as part of NOAA. In essence, we were developing our own prototype for rapid attribution, focusing on heat extremes and drought extremes in the United States. And if you're interested, we have a recent paper sort of on our methodology from last year. And the really, one key point in this attribution group, especially to get started, was to try to understand this lack of extreme heat in the central United States. And so if you're interested, I won't go into too many of the details about this warming hole, but we did publish a paper on this that sort of went into that this is very much related to actually a wet acceleration of a hydrological cycle. But again, this goes to the point that for monitoring climate in real time has challenges that we need to not only describe the influence of climate change, but also just that variability from weather and natural variability, decadal variability. So I think this goes back to, again, the importance of real-time climate monitoring and talking about regional climate change. And there's also been some work that we've gotten into more recently to incorporate different ways of thinking about attribution. So one of them, we decided to look at machine learning, particularly artificial neural networks, explainable ones at that, to try to understand maybe we don't see a clear trend if we just take an aerial average or simple signal to noise, but can we use nonlinear methods to really disentangle this climate change and climate variability? So this is just one, attribution-like method that we're currently exploring using new AI methods. And I think they poses a lot of really exciting opportunities, especially getting into this explainable and interpretable AI that can really get us more closer to sort of not just this black box of machine learning, but learn something new about the climate system. And I think it gives us a lot of exciting opportunities, especially incorporating these rich data sets from like climate model large ensembles with our observational data. And so, of course, there's many questions that we're thinking about with these types of new AI methods for climate monitoring, for attribution. And there's been recent institutes developed to think about this, particularly the ethics and trustworthiness. So this is one organization that has been spun up now for a couple of years, really thinking about how we can incorporate trustworthy and ethical and reproducible AI for climate monitoring. Currently, I'm now at Climate Central, and one attribution method that the group has been working on well before I arrived is their new climate shift index. Again, getting at, instead of just, spatial means of attribution information, this method instead provides local attribution methods. So you can go to a specific region and see day to day, again, in real time, how much climate change is shifting the likelihood of an event. So on the left-hand side, you can see just from a few days ago, we had extreme heat across Canada, which led to wildfires. Actually, right outside my window right now is a lot of smoke from the wildfires in Canada in the sky, completely blocking out the sun. And so you can see that using this new climate shift index that Climate Central provides, you can go explore this tool, that parts of Canada saw heat that was 5 times essentially more likely, and very likely an event that was influenced by climate change. And for the US, as I've been mentioning, regional information is so important. So the rest of my talk, I'm going to be talking about how we monitor, climate data and provide this as a resource in the US. And so really, essentially it all goes through, or much of it through NOAA. And one way we sort of disentangle all these regional climate patterns is through regional climate offices. So we have multiple climate offices spread across the United States, and they provide sort of local knowledge and tools geared to their users and stakeholders. They really understand, for example, the agricultural needs across the central US and can provide tailored information. But unfortunately, I have to mention what we're facing in the United States right now, and its challenges due to budget cuts and loss of funding. So just a couple weeks ago, actually all or most of the regional climate centers were actually shut down temporarily because the funding was not renewed to support them. And again, these are key centers for weather and climate information, not just about climate change, but just basic information, particularly like for farmers, growing degree days, frost and freeze information, crop information. Fortunately, the contract has been temporarily renewed for the climate centers, but they very much have an uncertain future for the services they provide. So here's just another map of how, again, we break down some of this information for these local climate offices. Again, the key component of climate services in the United States is very much providing local and regional information. So here's an example. If you go to one of those websites, this is from the Northeast Regional Climate Center. So this is one of the more densely populated regions of the United States for the major cities like New York City. And so you can get lots of different tools and maps of information that local stakeholders within this region are looking for. So here's just an example of that type of information, particularly for hydrological purposes. We also have other centers that think about things like climate adaptation. So here's one of the climate adaptation partnerships, again, focusing on regional knowledge and information that is so important when we talk about this type of data and provide tools to monitor it in real time. There are many of these different types of services. So I think a positive in the United States is that there's a lot of regional climate information, but I think something that's quite a challenge for climate services is that all of these tools and regional information are not together. So there's a lack of coherency in finding this information. Different people, different offices provide it. So if you're a user trying to look for this data, sometimes it can be really hard to figure out where to start. We also have a state climate program. So many of the states, almost all of them, have a state climate office, again, providing even more local knowledge and information on things like weather and climate data. So I'll show an example for these offices. Some of them are much more, quote unquote, organized than others. So here's an example of the Colorado State Climate Office, which provides wonderful tools for its users, just showing some of the information that can be provided for Colorado. So here's an example of some of the maps and different information of things like precipitation and snowpack and agricultural things that are quite useful. Also, information on like avalanches and information for water resources across the western part of the state in the Rocky Mountains. We also have another center that's focused just on drought information, providing weekly outlooks across the United States for drought. So here's an example of the drought monitor. But again, we have this information, but this is yet another office and resource you need to go to look for this. We have another new office focused on heat, so trying to think about heat extremes, particularly how it affects health. So this is coming from a new institute focused on providing this type of information, both in terms of prediction and current heat risk across the United States. Many of these products and data resources are all coming from NOAA. And so here's an example. If you go to the National Center for Environmental Information, you can find many of these data that then get used for all of these different stakeholders in climate service offices. And so here's just an example of sort of dashboards that have been created by NOAA to monitor some of these larger climate indices in real time. But I have to mention, as I wrap up here, that a challenge is that many of these wonderful services at local and regional scales are at risk. So data is at risk. Here's an example from the National Snow and Ice Data Center, which provides key information about snow, for sea ice, for glaciers that are all used by different stakeholders across the United States. Now, acknowledging that they're going to be reducing the amount of service that they can provide for this type of data. We're also seeing, major data sets that are used, across the United States for many industries, economic industries, the insurance industry. So this is the billion-dollar weather and climate disaster products will no longer be offered beyond this year, which is a really key data set that has been used for many, many years. And just wanted to also point out, again, all of these resources are at risk in the current proposed budget from the presidential office, which essentially eliminates all funding support for anything under NOAA research. So if you're familiar with NOAA acronyms, this is the Oceanic Atmospheric Research Wing of NOAA. NOAA OAR has no money supported in the current proposed presidential budget. But I'll mention this is definitely not the final budget, and there's a complicated sort of budget system. But again, these are the types of services and challenges we're now facing in the United States for climate data. And I saw this article this morning, and I just want to read it because I think it really summarizes what we're facing right now in the US. One climate scientist who declined to speak on the record out of concern that the administration might punish his institution said the declining funding is forcing researchers to shrink their scientific ambitions down to a question of, what can I do with my laptop and existing data sets? And again, so we have many wonderful climate service offices and wings that monitor the data in real time, but these are very much at risk of continuing. And, a goal recently of NOAA has been to expand climate services. There was an initiative called Climate Ready Nation, really to think about providing climate data like we do for weather information from the National Weather Service. So this is very much still, our ultimate goal is to kind of combine all of these services together. And I think there's a lot of, opportunity for Copernicus to really help fill in some of the gaps that we might experience going forward into the future for climate services. And there's a lot of challenges, as we go forward about climate change. Where do we go in the future for, above pre and the climate, Paris climate thresholds, and how do we disentangle things like climate variability and extreme events are all important questions going forward. And I'll end here with what I always think about when I communicate and think about providing climate data, and is stop thinking like such a scientist, but keep in mind you're an expert on working with data and how can you provide accessible data for all users. So I will end here. Thank you.
Wow, Zach. Thank you for your words. I don't know if anybody here has any question in the audience, online. Yeah, we got one here.
Yeah, thank you very much for your talk. It was really fascinating. I loved the visualization part is something that's close to my heart, and as is communication. But leaving all that behind, I think it's really, it gives you goose pimples what you talk about from the political setting. So rather than shaking our heads, as I think I can even see people here doing that, because being from the same field as you unfortunately you're not with us, but I think there's an emotion here about this. But I'd like to know is, what can we here in Europe, as many of us are data scientists, do in a way to support you in some meaningful way that goes beyond just throwing our arms up and saying, isn't it terrible? Is there anything we can kind of think of doing to support the United States scientists like yourself in this situation?
Yeah, absolutely. Thank you for your question. I think there are some things that, would be helpful. In many cases that, the scientists being impacted working for federal agencies really cannot speak out even about the importance of their science. So I think really elevating the importance of the data and science that's being provided by organizations that know, I know everyone in the audience knows that all of our climate data, is succinct. We need everyone to work together. There are many data sets provided by all the institutions to create these wonderful products like from ERA 5 reanalysis. So I think elevating the importance of the work that's being done, what would be lost without a key data set. What if we lost, a sea surface temperature data set provided by one of the federal agencies? I think so elevating the work where current scientists in the US are currently unable to sort of talk about that. So keep talking out, keep bringing this into the conversation. I think something's really important is not just to talk about it, this week and then, move on, but to continue elevating the importance of, international collaboration, both in terms of science, data, and service.
Thank you, Zach. Yeah.
Thank you, Zach, for the excellent presentation. Really enjoyed. I don't know where to, probably over there. Carlo Buontempo here. My question was building on the previous one, and it was about the discussion within the US and whether there is part of the community who's reflecting on the situation as a lost leadership, in a sense. So in a sense, in many of the things you presented, the US was a guide, was a reference point. And in a sense, this can cause long-term damage to the US by losing leadership and visibility internationally. So is there part of the community in the US reflecting on this, and how is this surfacing in the public debate? Thank you.
Yeah, absolutely. Thank you. I think many of us are having conversations because we acknowledge and realize that any gaps in terms of leadership, any gaps in terms of data is really a terrible tragedy to our understanding of weather and climate. For example, for the sea ice record, we've had one of the wonderful things about the sea ice record over the last 40-some years is that we've had consistent observations spatially and temporally. So, if we have a gap of a month, that would be devastating to our, understanding and our understanding trends and key data sets. So we're trying to coordinate and figure out how we can fill in these gaps, how we can continue continuity. Continuity is so important for things like climate services and monitoring. So, we're having these conversations, different organizations, maybe non-federal, are trying to think about ways that they can contribute to this conversation. So it's very much, we're a work in progress, but we're thinking about this. Another challenge has been even just travel to international meetings right now is quite difficult for federal scientists. Going to conferences like EGU was almost nearly impossible. So, how can we continue to have a presence for international scientific collaboration, which we all know is so key for the problem of climate change?
There's any other question? Okay, so Zach, thank you very much. Give him please an applause.
Thank you.
So next, we have a panel discussion on the evolving and changing nature of climate monitoring. It is well known that it has evolved significantly with advancements in technology and access to more accurate data. For instance, Copernicus plays a key role in the media. We use it to report on extreme events and long-term climate trends. Before, Florent said that it is hard to find a scientist on prime time, and it's true, it's really hard. So what we're trying is to bring all this data and images from Copernicus to that prime time. So that really helps in contextualizing all the information we give in the weather section, and it's actually well received. So we are really grateful and thankful to Copernicus. So for the next roundtable, I'd like to invite the following speakers to join me on the stage. Samantha Borges from the ECMWF, Padres Flaherty from Met Iran, and Barbara Shimani for EUMETNet. Please give them an applause.
Thanks so much, and thanks to Zach for the fantastic presentation. So I've just got a couple of slides to talk through. Sorry, I don't know if I'm double miking here, so I'll stand back here. A couple of slides to talk through the changing nature of what C3S has done. And as we've heard this morning about the state of the climate, the global climate highlights, the monthly bulletin monitoring, We're also celebrating our 10th anniversary in September this year of the monthly bulletin, our climate monitoring. But what we've seen from the last 2 years of exceptional climate temperatures is we're living in climate change right now. It's no longer a future problem that we need to use climate projections for. We really need to understand what's happening today. And the uptake of climate data has been extraordinary. So we've had the United Nations Secretary General, Antonio Guterres, use our data and refer to the Copernicus Climate Change Service and ECMWF several times through his compelling speeches. We're also partnering with the WMO regularly, and other UN agencies like UNEP are using our data in their reports. And I think one of the fantastic things that, in the room, most of us are scientists, so we love data and statistics. And these are statistics from our wonderful Copernicus communications team to really showcase the impact of our products. And this is a snapshot of how the Global Climate Highlights has evolved through time. And you can see for 2025, which was based on 2024 data, where we partnered with NOAA, NASA, the UK Met Office, and the Hadley Centre to release data, and Berkeley Earth to release data all at the same time. You can really see the uptick in exposure that got us by having this joint approach and ensuring that all the global data producing centres were saying almost the same thing at the same time. And then when we look at the European State of the Climate Report, which Rebecca showed some examples from before, and Florence in her keynote this morning gave some statistics, again, we see growth year on year, which is really important because each year we're evolving what we're covering in the science and how we're reporting that science. For me, I'm incredibly proud of the work of the climate intelligence team. It's very much a team effort. Not so much with the team across ECMWF, but the broader C3S community. And one of the products that is a year and a half old now is Climate Pulse, to speak to that need that Zach was talking about of having data on demand. So it's a very simple application where we can see climate air temperature anomalies, sea surface temperature anomalies, spin the globe to find out where you are, and look at the situation from 2 days ago, which is hugely exciting. And finally, we talked about the European State of the Climate. One of the highlights this year was the European Commission. We had a quote from one of the commissioners, which was really exciting. We're investing so much additional effort in these compelling data visualizations to really ensure this data is as accessible as possible. And this is a slide courtesy of Rebecca, but behind the glossy report and the 120 graphics that are there on the graphics gallery, I really want to highlight it's such a team effort, and there's a huge amount of work that goes in each year. So from a team perspective, the first 2 quarters of every year are intense, intensely insane, insanely intense. But now we're in the downside of this, so we really welcome conversations with all of you here of feedback of what we're doing, how we can improve it, how we can engage with National Met Services even more to make sure we're highlighting your data, your in situ observations, and really build these bridges between what the National Met Services are delivering and what we're doing at Copernicus. So with that, I'll end and look forward to the panel discussion.
Okay, hi. Oh, hello. Sorry for blocking your view, first of all, everyone. I'm Pádraig Flattery, and I work for the Irish Met Service. I'm just going to give a little brief introduction about what we do and potentially how things could be improved. So like all Met Services, we've been engaging in climate monitoring for decades, where we take our station observations and we create climatological normals and produce gridded data sets of historic climate. We have a network of hundreds of rainfall and temperature stations, but it's expanding and becoming more automated as the data and the technology advances. And climate monitoring have improved significantly over the past decade, and Met Éireann have gone from it being a part of our research division now to having a dedicated climate services unit, where we have now not a huge amount of people, but over 10 people now working exclusively on climate services. So as part of this, we coordinate Ireland's national framework for climate services, which is a central hub for bringing producers and consumers of climate data together. And it aims to facilitate access to climate projections, and these have been used recently for national adaptation plans. But as well as that, we want to get our climate monitoring data out to as wide an audience as possible and to get feedback to try and improve that data. So in relation to enhancing that climate monitoring, we have projects working on data rescue, going back to historical rainfall records from the mid-1800s. And we've engaged with the Copernicus data rescue ecosystem, and we're keen to do more in this area, particularly when it comes to advances in AI and in digitization and transcription of data. So we've also recently invested more in artificial intelligence in the form of a €5 million professorship, which was awarded to University College Dublin, and it's going to have 20 PhD projects over the next few years, which focus exclusively on AI advances in weather and climate services. And one of those projects is going to be on automated quality control of our observations, which is currently a very human-intense process, but ideally would be replaced by artificial intelligence processes. So we also use the Copernicus monthly bulletins to provide context to our own climate extremes, and this is becoming more and more common. Almost every month now we have a certain statistic that a station has broken a record for rainfall or temperature. It was our warmest year on record in 2023, and our wettest year. Last year was our 4th warmest on record. And this spring is going to be our warmest and sunniest on record, it's looking like, with the statistics. So we really welcome the inclusion of Met-Éireann's data in the Copernicus bulletins whenever it's relevant. And yeah, sharing our latest science with them is always a benefit. We get much more engagement with our things when it's mentioned by Copernicus. We're also aware of enhancing the communications through visualizations as a key way of getting through to the public and to diverse audiences. We really appreciate the work of Copernicus and the guidance from Anna, who's given us a talk from Met-Éireann, and has really kind of set the standard for climate visualization that we're trying to emulate, at least try in certain ways to do as good of a job as Copernicus do. So we're a relatively small Met service, but we're making progress nationally, and we really want to push this further and yeah, take advantage of the tools and methods that you've all have developed and just learn from other Met services, see what you're doing and what we can do better.
Thank you, Badresh. Barbara.
The Met services and Copernicus are working on a very similar area, not to say the same area. So there are a lot of topics where we get into contact with each other. Of course, with all the preparation of the European scale data, Copernicus is very valuable for the national Met services to place their national information in a broader context, especially with all the reports you are providing, but also with the European scale data sets. With all the open data now being more available, and with the data sets available on the national scale that have a lot of the regional knowledge included there, there might still be some link missing to those national data sets from the broader scale. So just also for the users of Copernicus starting to have an interest in climate and looking through all the information you provide there and getting more and more interested also for their own information, it might be good to have some link to make it easier for them to find the information they are looking there for, provided at the national level. There are also a lot of challenges we might share. For example, the AI and how to use it for the data sets as well as for the reports. There might be some possibility to connect here on how to do it as well as on how should the data be prepared at the different services so that others can use it and include it easily in their products. There are already some cooperations ongoing, like, for example, on the discussions between the Met services on how to unify their information to make it easier to compare the different national results. For example, on the climate change level, where they've now discussed or decided, or a number of them decided to go for a common method called LESS, where Copernicus is also thinking of joining this activity to make it more comparable. That's quite a good cooperation, I'd call it. And maybe in the future we will find other opportunities to unify the information we are providing to make it more comparable between the countries and also the European information. We very much appreciate the availability now of this attribution service, which is an activity that most of the Met services are not able to deliver on their own due to the big effort needed for that. Yeah, I think so. That's the first informations.
Thank you, Barbara. Thank you all. So we have some online questions I'm going to read for you. From the national perspective, how useful is the European State of the Climate report in communicating climate information?
We find it incredibly useful because once it comes out, we tend to try and time our previous 2024 report in advance of it so that we can kind of double up so we can get as much coverage as possible for it. We also kind of, when we can get a sneak preview of some of the graphs that you guys send on, we can try and recreate similar ones to try and contextualize some of our stuff. So we find it an incredibly useful resource. Yeah.
Thank you. How has the role of national meteorological services in climate monitoring changed in the last decade?
It's changed quite significantly. As I mentioned there, we didn't have a climate services division in Met Éireann up until probably 3 years ago. So it was kind of a side aspect of research, whereas now it's becoming much more in demand from the media and from the public in general. But even forgetting over the last decade, over the last year, the progress with AI now seems to be pushing it much further. I mean, I mentioned earlier in a question at EGU that people are displaying things that should take a lot longer to do in very short spaces of time. As part of this professorship that we funded, one of the kind of interesting projects that we thought would be useful is a summer project to create a kind of chat GPT for our weather forecast. You could go onto the website, say, I'm going to cycle from Dublin to Galway tomorrow. Am I going to need a jacket? Can I do it without any, what kind of weather can I expect? And the student was going to have 2 months to do this. And at our kickoff meeting, so he had started 5 days previously, he's finished. He's already done the project. Mm-hmm. So that's an undergraduate maths student who has completed what we thought would be a 2-month project in a week. So there's going to be a lot of, the pace of this is very hard to keep up with, I think. And I'm not sure how all the developments can be communicated from a higher level at Copernicus or at UMetNet to all the Met services so that we can actually take it all on board because there's just so much information. So, yeah.
Barbara, how has the role of national meteorological services in climate monitoring changed in the last decade?
In the former times, climate monitoring was mainly consisting of providing some climate normal periods, some national means and some extremes. And now it's much more focused on services, on more user-driven products as well. The range of topics covered got broader, also the availability of data, of parameters available on the grade of detail that it is provided in got much higher. And it's much more asked for now.
Okay, thank you. Samantha, what are the largest emerging demands from governments or the public when it comes to climate data and monitoring?
That's a really tricky question. I think from journalists, the biggest demand is accessibility of data. So we have a lot of internal conversations about accessibility, particularly of gridded products where your general data journalist can't read a GRIB2 file. So how do we ensure the data format is right for the data to be as accessible as possible? In terms of governments, it's, we've got a representative from DG Klima in the room, and it's really interesting when we hear feedback from the European Commission in particular of, they like hearing the C3S perspective rather than a attribution study from a group of scientists that are affiliated with an institution in one country. So it has that trusted, authoritative voice. And I think getting that feedback of what decision makers need in terms of how they need data to make decisions, that then enables us to go away and think about how we create data visualizations or applications that speak to that need. So it's very much about the co-creation, but the conversation needs to happen of what do they need data to do and how do we provide it in a format that works for them.
Thank you. Padresh, and are we doing enough to engage end users in the co-design of climate services and monitoring products?
Yes, probably not. We could probably always do more to, engage people in general. We do now have a national framework for climate services in Ireland, as I'm sure other countries have similar ones or have them in development. But I think while they're there, it's very difficult to engage all the sectors that you want to. It's very difficult to enact everybody's desires in a way that pleases everybody. So yeah, it's a big challenge. It needs resources thrown at it that kind of are limited at the moment. So again, yeah, collaboration and help from other countries, seeing what they've done better, and from Copernicus in general is always welcome in that area. Yeah.
Yeah, interesting. Barbara, are there opportunities to make the European State of the Climate report more useful for the national level climate planning or the public engagement?
Of course there are, there always are.
Yes.
We had a specific meeting on that with Freya some months ago, where we just collected some input on what could be valuable, like increase of parameters or different time slices that might be of interest. But it might also be of interest what of the products the national Met services are creating in kinds of reports might be interesting for Copernicus. So that would also be a question that...
Mm-hmm. Thank you. We have another one from the audience. Carlo? Microphone, please, here. Thank you.
Thank you, and sorry for the long walk. Actually, it's building on this last comment, because also before you were sort of mentioning that one of the aspects we can strengthen is this interaction with data set available at the national level. So it's a question and a comment to some extent, and is how can the National Collaboration Program play a role in that space, and how do you see that happening for different Met services? I guess it's a question for all of you.
The next session.
Well, I'm preparing for the next session, Sam.
Currently, this National Collaboration Program is very much focused on the national needs. But what I was proposing before was more like there are some reports on transnational areas written by the countries that I heard there might be some overlap with something Copernicus plans of doing, so where it might be useful to have some discussions as soon as some products are planned with the Met services, what's out there already. Maybe there is already something that could just be taken up or improved or just would need some more visibility.
Yeah.
Yeah, and I think we were asked as part of the National Collaboration Program to put together a slide on what we would like to get out of it, and that's exactly what's on my slide, is to integrate our climate normals and projections into that ecosystem. Yeah.
Do we have any other questions here from the audience? Okay, so we're out of time. Thank you. Three of you. Thank you. So now let's turn to Dr. José Manuel Gutiérrez, a researcher at CSIC and director of the Institute of Physics of Cantabria. José Manuel is leading work on regional climate variability and downscaling methods, which are essential for understanding climate change impacts in adaptation. He's a coordinator of the Atlas and the interactive Atlas of the 6th IPCC report, and is part of the ARE6 chess group on data support. On you.
Thank you very much. Yeah, hello, thank you. Can you hear me well? Okay, thank you for the introduction and for the invitation. I'm very happy to be here again. In Valencia, it's not my city, but my country. So I'm going to present the current status and future plans of the Copernicus Atlas. So there's a paper in the ECMWF newsletter where you can get details and more information about that. So you can get the QR or just Google search for that. So the description will be very, very brief to basically provide a brief history of the Atlas and the link to the IPCC work, then the current status and future plan, nothing fancy. So the idea is that the C3S Atlas is the evolution of the work done for the IPCC 6 assessment report. So this AR6 report included an innovative product, which was the Interactive Atlas, that was coordinated by myself, Richard Jones, and Teresa Narisma from UK and the Philippines, respectively. And the idea is that that tool supported the assessment done in the report, was an integral part of the report, and was published together with the report in 2021, and along with the report is frozen. So even though it is a digital product and can be updated, so this is supporting an IPCC report, and there is no further evolution of the IPCC product. So this is where C3S came into place, and they provided support for being the home of the evolution of the Atlas. So that initiative were continued in the future with the potential to feedback in the future again to the next IPCC report, which is the case currently. So, so the C3S Atlas is the evolution, updated with new data sets and indexes, all that fed with C3S information. So it's a C3S tool building on C3S data sets. Okay. And that evolution produced a more sophisticated tool, which is not now a single web application, but it builds on 3 pillars, in 3 main components, which are the data set itself, the application, which is the interactive application to display maps and so on, and the user tools, providing fair tools for reusability, reproducibility, and so on. So this is like a GitHub repository with notebooks to reproduce most of the processing done to develop the data set, so the data set is reproducible, but also the products that you see displayed in the Atlas. So it underpins, in a way, the software which is used for the different workflows underlying the Atlas. So it's fully open for the community. So the dataset includes a variety of C3S datasets for observations and reanalysis, because the Atlas, the main goal of the Atlas is allow for an interactive analysis of the past trends. This is where observations and reanalysis come into place, and the past trends are available from the standard observational products included in C3S, which are Berkeley CPC for precipitation, EOPS at the regional scale on the right. But then we also have reanalysis, this ERA5, obviously, ERA5 land, obviously, and Serra, going down to 6 kilometers approximately. And also information for the ocean, because we have the ocean reanalysis is similar to ERA5, but ocean models, and the same for SST observations from satellite information from ESA. So all those are data sets from C3S. And this is for the observations and reanalysis for analyzing what happened, and the same for the future. So for the future, we have CMIP 5, 2 degrees, CMIP 6, 1 degree, Cordex Core providing worldwide information at a 25-kilometer resolution, spanning most of the inhabited regions in the world. We have Cordex at the European scale, 11 kilometer, and you can compare the finer resolutions at the rightmost part for Sierra and Cordex EUR, which is the state-of-the-art in regional projections for Europe. So all that is available, but what specifically from those data sets? So the atlas includes variables and indexes, 35 in total, for a number of categories. It's heat and cold. This is mostly temperature and temperature-derived indexes, extreme hot or very extreme hot days, and so on and so forth. Wet and dry, drought, wind and radiation, snow and ice, sea ice extent, for instance, ocean SSTs, and circulation sea level pressure. So these 35 indexes on the right are available as raw information, just as coming out from the data sets, but also we include bias-adjusted versions. For those indexes, you have the cross mark on the last column in the table for indexes which are threshold dependent, and for those bias-adjusted versions are included, because that's the good practice to follow for those kind of indexes analysis and so on. So all that information is packed together and is published in a catalog. So the gridded monthly data set underpinning the Copernicus Interactive Climate Atlas, this is the short name. So you can access, as in any other standard C3S data set, the overview and the download information. You see all the data sets there and the different variables, so you can click, download, and all information is ensemble targeted. So when you download a projection, what you get is all the members together. You cannot download a single member because we don't support, in a way, the use of a single model. So when you get one, you get all, and then you are like recommended implicitly to use all of them, not just one. So all those good practices are included there, and that is the basis, so the data where the application sits, because the second component, the Atlas application, enables interactive exploration of that information in the form of maps, global maps. As you can see, this is for CMIP 6, I guess, in a number of projections which are useful for different purposes, like the standard Robinson for the IPCC kind of figures, stereographic north and south, and so on and so forth. So all those options are available in tooltips or toolbars in the application in a not user-friendly way that I will talk about later. So it's getting more and more complex. But besides that, you can select a particular region. This is Iberia, so it's Spain in particular, and click on the regional information button that displays spatially aggregated information in a number of visuals. So you have time series on the top, you have the climate stripes, the rows in that figure are ensemble members, so you see the whole ensemble there for CMIP 6, the annual cycle, and so on and so forth. So you have all that information is available, is pre-computed for a number of predefined sets of regions. One is the IPCC, standard regions, the subcontinental IPCC regions, but in the Atlas, in the C3S Atlas, that was expanded to countries for Europe, and also recently, the latest version for selected cities, because in the last version, published in February, we published city scale information following Cordex flagship project on urban scale that I will mention in a minute. But besides that, the user can draw in the map a particular region of interest, and then the same information can be computed offline and then displayed. This is not interactive, but it takes a few minutes in most of the cases. So it's full flexibility, which was not the case for the IPCC Atlas, because the IPCC Atlas supports the assessment done in the IPCC report. And the IPCC report in Working Group 1 gets down to the IPCC reference regions, but not below. There's no information for countries, there is no information that you can draw and get, because this is not IPCC's business, it's climate services business. So in principle, things fit nicely. So you can export all the products with the different formats, NetCDF, both the data and the metadata. And just a couple of hints for in this latest version, version 2, published in February, we included a couple of extra functionalities. One is monitoring. You see in the figure, what you see in the lines are different years. So year by year, you can display the information for the seasonal cycle. So this is month by month. So you can pick record-breaking events or follow the state of the climate for the 35 indexes which are included in the Atlas. And this is, for instance, extreme hot days, maximum temperature above 35 degrees, okay, for the Mediterranean region. So where you can see that 2024 was also a record-breaking event. The same with all the indexes. So this, in a way, complements the real-time polls, but does not overlap, because in the Atlas, we only include complete years, so it's 1 year delay, whereas the pools is real-time, has a different purpose. But the idea is that all C3S applications complement each other, and that's one example. So again, with the city scale information, so this is available only for the high-res projections plus Serra, because in Serra, the city component was included in the regional model used to do the downscaling. So the idea, very, very quickly, because tomorrow you have in the demo booths, there is one demo for the Atlas. So if you are interested, you can go there. So there's no point to explain in detail. But basically what this new element gives you is the difference between the urban versus the rural area for selected cities. So when you click in the Atlas you define a region around Paris, for instance, the information that you get is the average. So it doesn't differentiate the city versus the rural area. When you go to this tool, you get finer detail, and you get this difference explicitly, because the tool uses the urban and rural areas, the masks of the different models used for the projections to separate these two contributions. So you can display one versus the other. So if the red is urban, the green is rural. So you see there a 2 degrees difference for Paris, for a particular regional climate model on the left. Okay. So this is implemented in the tool. So this is the Serra data set for the selected cities, predefined set of regions. So you see London, you see Paris. Maybe Paris is not here. So I get the chance to move a bit because I like moving, and this is very static for me. So by selecting Paris, you can get all those products that I mentioned. This is the time series. So this is the annual cycle. This is for frost days, minimum temperature below 0. So you get up to 10 days per month in Paris. And when you display the urban minus rural signal, you see that in the city, the number of days are lower, are almost half. So this is the urban heat island expressed for the frost days in Paris, as coming from the Cordex projections, in this case, the Eurocordex. So the third component is the user tools. So the user tools is basically a repository with notebooks and software. So the user can go through the different pieces of the post-processing for generating the Atlas dataset on the top or the Atlas application on the bottom, and see and reproduce how this was done. So this is an example of how the extreme hot days, so daily temperature maximum above 35 degrees, has been computed, bias adjusted, and all that is included there, because I mentioned bias adjustment, but you may wonder which particular method, which particular configuration. All that is very, very tricky. When you try to reproduce things, it is many times very, very difficult to get right to exactly the same configuration. So if you don't go open, things are difficult. This is the way to go open. So, and finally, so what's next? The future plans. So the good news is that, particularly for us, is that the C3S extended the contract for the Atlas for 3 years. It is good that it is very, very well aligned with the IPCC AR7 timeline. It thinks that it is on purpose, but it wasn't. It was by chance. But chance sometimes help, and this is the case. So the future developments will be guided by C3S priorities. So this is leveraging C3S data and infrastructures. That's key, that's the point. But at the same time, aligned with IPCC AR7 activities. So what we do in these 3 coming years can be recycled back to IPCC again. So we contribute in 2 ways, which would be fantastic. So we propose we need to wait how the new teams of authors get elected and configured, but the idea is that we will propose to establish a coordination group with IPCC representatives, the technical support units, which are already contacted, are happy, authors will come. So we align both the C3S Atlas with the atlases to be developed in the IPCC AR7 in the best possible way. Obviously, depending on IPCC interest and depending on C3S interest. Okay? So there will be a continuous integration of new data sets, and we have the radar on Cordex CMIP6 is the next data set coming. So it's the high-res projections from the latest version of global projections. But then very quickly after that, CMIP7 will be in place, so CMIP7 will be also included. So the idea is to publish a new version every year, but the integration will be continuous. So the dataset will be evolving continuously as well as the application. So one big thing to do is the simplification of the Atlas structure, and this is beyond simple and advanced interface and simple things like that. So the idea is that now the Atlas is getting more and more complex. So there are tons of information there, which is very difficult to dig. So the idea is that we need to think, and we have ideas on how to present the information in a way which is useful for different users, for different profiles, for media, for researchers with low experience, little experience, sorry. And so on and so forth. And all that, we have ideas on how to enter gradually and to go layer by layer, getting more and more information. And this is something that we will explore hand by hand with the ECNWF in this next cycle. And finally, you cannot see that because I use all possible area in the slide to put information, as I do usually, but for you and for me. But the expansion of the user tools and their integration in the C3S Jupyter Hub. Now, you can run the notebooks locally, you can use Binder, but the idea is that this can be run to some extent with some limited resources directly from the C3S infrastructure. So you can just enter and play. Obviously, not reproduce the full data set because it takes 2 months in a supercomputer that is done specifically for the contract, but you can reproduce pieces, subregions, and so on and so forth. And that's all. Thank you very much. And remember, at the demo booth tomorrow, those interested. Thank you.
Thank you, Dr. Gutierrez. Let's see if there's any question from anybody. Yeah, you have two. Yeah, wait for the micro.
Thank you, Jose. I'm a big supporter, I'm a big fan of the C3S Atlas, and it's nice to see all these improvements. I have a comment on one of your last points behind the seats. Last year, I had an opportunity to use the Atlas as a tool for educational activities in schools. And it was really amazing, and students used the Atlas as a way to access data and to do little research and even write small papers. So I think that is one possible, very important audience of possible users to take care when you design different group of users. Thank you.
Yeah, thank you very much. We are aware of that, and I forgot to mention, and this is very important, that we will include as soon as possible in the Atlas some way allowing users to provide feedback, and feedback not on I like it, I don't like it, feedback exactly on that. So if you use the Atlas for some specific application, which could benefit from the Atlas, and the Atlas could expand that several ways. So we would like to hear that, because we know this is being used in schools, in the university, and we've been approached, particularly in the Atlas, IPC Atlas case, by several teachers and so on and so forth. But so we want to strengthen the potential support that we give to that, even sharing material or sharing experiences. All that is part of this new way of using the Atlas that we are planning. But I would appreciate very much if by that time you could reach us and share your experience. We can put you in close contact with others which are also using the Atlas for that, and that would create a community that we are very eager to see growing.
Hello, good afternoon. I am also another fan of the C3S, so congratulations for this great job. But I wanted to ask you two questions. First one is regarding this 3-year extension, and I have seen that you have also included this Cortex Urban, which I think that is really interesting. And I was wondering, because I haven't seen in any of your bullet points there, any integration of the Destination Earth high-resolution projections. And I was wondering if that is in the plans or not. And second question is with regard to the different type of users. I think that it's a great idea, these notebooks, public available, so that most of the researchers can use them. But I was wondering about other type of users, that they are not really, it's not easy for them to access notebook. It's just, if it's a notebook, I'm not going to use it. I am speaking about municipalities that they need this information for the CCAPs or other type of production that they do. So are you thinking about other types of or ideas for this type of users?
Yeah, thanks very much. Yes, definitely, because that's what we want to do. So this is the type of stakeholder, policymaking kind of activity that we would like to support better. And better means that if you enter in if I work in as you mentioned, at a government level, and I want to do something for my national adaptation plan, so this is not easy. So we need to have a different entry. So you see countries on the top, and then you see other pieces of information or organized in a different way. So the user tools, the name is very, it's not inclusive. I agree. It's not intended to be that thing. It's just the element to grant reproducibility and reusability, but it's very specific to practitioners. So it's not there. And second, destiny. So the idea in the atlas is to provide comprehensive information for all the data sets. So every index is computed similarly for all the available data sets. So we need a long enough historical period, a long enough future period in order to compute 30 years, warming levels here, trends there. So destiny is not at that point yet, because they don't produce long time series now, long projections, so they are going very deep in resolution, but have limitations, struggle with the production of decadal centennial simulations. So we would be happy and to include in the atlas whatever is used for assessment and align with the IPCC, we'll see. So if that gets to the point, we will obviously include that. Okay, yeah, on Wednesday there is a whole session on that, on the operationalization and climate projections, and I think Destiny will be involved in the discussions because it's the branch for that. So, but yeah, we are not biased in the view. So basically, it's what the C3S view is the view of the C3S Atlas. So.
Yeah, and the last question, I think.
Thank you. I wondered if you could tell us your view, potentially with your IPCC cap on, as to where the Atlas should stop. It's very nice to hear people say, add this, add that, add the other. At which point do we stop and let people downstream of the Atlas and downstream of C3S take on some of the user applications we are talking about? C3S will decide in due course, blah, blah, but I'm curious to see your view on this.
I don't think I got your question right. So, yeah.
Well, we take all the data sets available, we go to scale of countries, we go to scale of users within the country, at which point this starts to conflict with more specific interest in that particular country. At which point should C3S stop? And should national interest possibly start? You're talking about municipalities, regions. Also, there is the point that you mentioned somewhere. The idea is to keep the same rigor and the same methodology the IPCC has endorsed. As we know, the IPCC has not endorsed all these very fine spatial resolution stuff. So where do we stop?
Now I got it perfectly. So I needed that. So this is, to me, connected to the National Cooperation Program that you recently started. And my view, which is my view, this don't take it as a good one, is that so at some point Copernicus need to stop and need to engage with the countries in two ways, because different countries have different observational records, different needs, different ways to treat that, creating grids, a very high, intermediate resolution. So there are a lot of country-specific information and practices which I don't think can go top-down. Needs to be neither bottom-up. It needs to be both ways. And I think the National Cooperation Program is a very nice initiative for that, because if you, for instance, focus on a particular country for a particular application, so could be an application to provide very high resolution climate projections, doing downscaling, blah, blah, blah. So that could be like a frame as a case study to be followed by others, at least to contrast what they do with this reference and improve. So you can both learn. So I think Copernicus has a natural way to stop at some point, which obviously is not my. I think you have already the instruments for doing that with the National Cooperation Program. If you iterate a bit on that, so you can For instance, in the call, prioritize things which require good practice, and there is not that good practice there, and not replicating things that are proposed similarly in different, but just ideas. Yeah.
Okay.
Thank you.
Thank you, Dr. Gutiérrez.
Thank you.
So, Leslie, we have Professor Bart from the HUORC, co-chair of the IPCC Working Group 2. Bart is an expert in weather and climate information, and he has been a leading voice on integrating climate science into adaptation strategies. We're delighted to have him join us remotely. So, Professor, please proceed.
Thank you very much for the short introduction. And indeed, I was actually working with Jose on the interactive atlas of AR6. And you know, I'm now also proudly presenting work from Working Group 2 that is planned for AR6 for an atlas. And I will promise to come back on that very intriguing last question: what is, say, the final stop of a service like this? That is an interesting pathway to discuss. But let me first present a couple of priorities that we put together in the scoping process of the 7th cycle, and I'm emphasizing Working Group 2 perspectives here because that is my working group. But I can assure you that we have a very close collaboration with the Working Group 1 co-chair Robert Foutar and Xiaoye Zhang on the mutuality between Working Group 1 and 2 atlas products. But let me very briefly introduce you a bit where we are currently, and that is a short overview of the plan of the 7th assessment cycle. And again, I focus on Working Group 2, but there is quite some references to others as well. As you know, we are running a special report on climate change and cities, and so it's been very helpful for the audience that Jose already presented the Copernicus capability to zoom in on city scale. And I can assure you that if you start a discussion, where should we stop, and do that discussion with individual city representatives, that ending is very far into the future. There is an incredible demand for even more and more. And I'm not even sure if a national collaboration program is going to set a natural finite position. But where we do stop on city scale, also for IPCC needs to consider, strong representativity biases. I'm not sure, I didn't dive deep into the current functionality of the Copernicus service of city. It's really, really interesting. But we see that there is quite a big difference in availability of this kind of, project resources and data resources between Global North and Global South on the world. And we would be very keen to avoid in IPCC a very strong cities report informed primarily by Global North data and project and research outcomes. So we really look for modalities where we can also, sophisticated presentation of Global South data in there. We are going to develop an atlas there as well. It's not officially scoped in the outline and approved, but we have had the first lead author meeting of the other team in March last year. And as you may know or not, but there is one chapter that is strongly dedicated to the sort of the demonstration chapter for cities. And the CLAs of that chapter actually it's chapter 5. It's the last chapter in the cities report outline. And the coordinating lead authors mentioned that actually it's the chapter 1 for the practitioners. So they use that as sort of a starting point. And there the outline is developed with the idea that these IPCC reports have so many dimensions, so many scientific concepts that at the city scale everything comes together, and then really detailed and local contexts matter a lot. And that is impossible to really robustly assess throughout the whole report, because there is so many dimensions by which cities differ. You cannot approach every chapter in that report according to all these different dimensions and consistently look at how The hazard profile coincides with the shape of the city, the economic profile, the coping capacity in terms of adaptation, the mitigation potential, the enabling conditions with finance, etc. That all gets too detailed. But the chapter 5, the case study, that's what we call the case study, of course, can afford to run quite a few case studies to actually illustrate how it works in practice. But again, like for AR6, we cannot afford to produce an atlas with hundreds of case studies, with hundreds of figures and storylines. And like in AR6, where all these maps with all these models and all these data sets went digital, we are now also planning for the case study atlas to go to a digital case study resource. But only to pick up on José Manuel's talk, also for the general assessment report, which comes out later. The timeline hasn't been settled yet, but we expect somewhere 2028, where work group 1, 2, and 3 reports come out. In both work group 1 and 2, an interactive atlas has been approved as part of the outline. And so we will produce also in working group 2 an interactive atlas, not only an annex as was produced in AR6, which was a static paper copy, but here again with the same philosophy as the work group 1. But let me detail you a bit on that in a minute later. Where we are in that atlas is here in the working group 2. Of course, has a very strong mandate to look at climate impacts, climate vulnerability, but also climate adaptation. And in the working group 2 outline, we have followed a kind of a basic philosophy that there's a lot of, say, global elements that we need to assess, like how is actually the development of the vulnerability and the risk patterns over the world. And we can, do updates relative to AR6 on these burning amber diagrams and the risk patterns and the reasons for concerns, etc., at the global scale. Again, like in AR6, we need regional chapters as well as some more thematic chapters, say sectoral chapters. But we really try to avoid the classical duplication of that. If you go for a regional chapter, you get sections on agriculture and infrastructure, etc. And then in the infrastructure and agriculture section, you get chapters for Africa, blah, blah, blah. Actually, we'd like to avoid it and look at this as like from a multi-dimensional point of view. So we try to enforce a very strong handshake between the regionalization and the thematic areas. And also in that context, we think that an atlas where we can bring in wherever we can make a connection to the physical information from work group 1, but also add additional layers on thematic areas, vulnerability, but then specified by income or by profession or by agricultural type or by economical structure. That, of course, is also for us a means to avoid these two separate lines of regional versus thematic, but to really produce a handshake there. So for us, it's a very, prominent feature in the outline. But unlike AR6, we don't have a chapter on Atlas. It is designed as a glue material, so to say. So let us discuss a bit on the plans. And you can imagine, I was part of the AR6 Working Group 1 Interactive Atlas lead author team. And now I'm Working Group 2 co-chair. And of course, I'm the same person. And I bring quite a bit of, experiences and my enthusiasm for that atlas I bring to the Work Group 2 domain, for sure. But there is, of course, also for me, a steep learning curve to go through, because where in Working Group 1 we had, we have talked a lot about, the protocols and the procedures and the averaging procedures and the scripting and the systematic approaches for all these data sets, as very well explained by José Manuel just before. And also these kinds of presentations where we are proudly already presenting, say, a multi-hazard perspective on the global world, so to say. And this is just a display, and people that know the Atlas know this kind of display as well, where we can combine multiple things. I'm just plotting it here because I also gave this presentation for a crowd that is a bit less informed on climate service and Atlas. So pardon me. And also this picture from chapter 12 in the Work Group 1 Atlas, where we can go region by region on say, a multiple lines of evidence kind of statement for hazards, which is part of what is reflected in the interactive atlas as well, as we all know. But now let's think working group 2, because what I would like to add, but I have to stress we haven't got the authors yet. We are in the process of selecting the authors from all the nominations that came in last month, and we have to work on this until at least October-ish. Not October, sorry, I was distracted. August, like before the author teams will be known and can actually start to work. And the first lead author meeting will be in December this year, and that is actually the first time that all these author teams come together. But let's dream a bit. I'm as a co-chair with some Atlas heritage. I allow myself to dream a bit because I do like to disclose these wide varieties of exposure data, which is probably a bit more easy and tangible than vulnerability data, of course. But again, a bit less easy and tangible than a lot of hazard data. But there is at least global data sets, and of course, there's also a very wide range of regional or country or even more economic sectoral typological data sets. Starting with base layers like population, asset distribution, maybe GDP kind of things as part of the vulnerability profile. We can also imagine that the author teams will chase deeper, detailed sublayers for those. Like at the scoping phase of AR6, we were happy to define this concept of climatic impact drivers, but you see how it evolves if you give these author teams a couple of years' time to develop more and how that actually contributes to it. So again, I'm really looking forward to that process to work with the authors on this. But exposure data, vulnerability data for sure is a key component. In the working group 2 ambition statement, we really put forward that an update of risk assessment of course requires an update of both the hazard profile, the exposure profile, the population is growing, urbanization is spreading out, that kind of things change also the exposure. But the vulnerability part was always the weakest part, even in AR6. It's also, of course, understandable. It's very difficult to define. It depends on a lot of social indicators, personal indicators. But it really is a crucial a new element in the global discussion and also the national or even regional discussions on who actually is exposed to climate change, who is most vulnerable, who is actually in charge of resolving the threats, who gets to pay the bill for who is to be protected. There is so much discussion about these distributional aspects of risks that we cannot avoid to make a much deeper dive in that vulnerability element of risk. And I know that is a tremendously ambitious statement to bring that to an Atlas version, but I'm sure if we don't put the bar a bit higher than the AR6 level, we are not getting there. And AR6 had huge gaps in its final assessment, knowledge gaps to be filled. And I could even imagine adaptation data. The Europe chapter in AR6 Working Group 2 had a nice, country by country comparison of, adaptation planning and state maturity of the adaptation planning, the maturity of the implementation, the finance part, the kind of scenarios they use, but only for Europe and only for sea level rise. I can imagine that we can think of adaptation measures now with the global goal on adaptation in UNFCCC coming up, all the indicator discussions. I wouldn't be surprised if we would be able to settle on a globally, uniformly acceptable layer of adaptation, because the adaptation level, of course, makes a huge difference to the final risk profile that we're facing. So lots of dreams to think about. The author team of Work Group 2 Atlas kind of things, chaired by Hans-Otto Pertner, who was the co-chair there, but they already made a sort of a visionary perspectives paper on what this Atlas could look like, and this is just a screenshot for that recent paper. And I guess it's straightforward to follow the risk propeller dimensions. We have the hazards part that is here on the left, where we can, of course, make use of what the Working Group 1 is delivering. But we need to expand on the exposure part here on this side, which indeed, as I said, can be linked to the population distribution. There is some information on vulnerability distribution based on key economic and health indicators, for instance, and demographic indicators can be used there. Yeah, and for response, it's still a bit a void, but there's something on the adaptation progress or adaptation reporting that could be linked to UNFCCC could be very well positioned here. A few comments on where we are and where we need to go, because as I said, we don't have the authors yet. This is all co-chairs, vice chairs, TSU. We have quite some interactions with the experts in the field. We also have had talks with Carlo Buontempo on Atlas propagation, and we have talks to the previous experts. But still, it has to be drawn and carried by the authors. And the selection, we of course keep an eye on the experience and expertise of the people that we want to select. That also for Working Group 2, we have an adequate subset of people that have experience or can be expected to provide it. The interface with Work Group 1, 2 is of course a matter of discussion as well. And Jose Manuel made me realize, and I just updated the slide a second ago, that we may also need to consider the question, what is the point of departure for Work Group 1? Is it AR6 or is it the Copernicus version of it? Do we indeed go on? But also for Working Group 2, where do we start from? The current thinking is we start from AR6 leftover, but that I think is under discussion. But that interface has to be discussed tremendously as well. Do we indeed settle for the similar grids? Do we take the same time horizons? Do we allow, cross working group combinations of data sets? The two atlases are carried by the two different working groups and formally have no connection there. There is, of course, informally a lot of discussions going on where we make sure that there is a good handshake. We, for instance, organize a lead author meeting for the Working Group 1, 2, and 3 assessment report author pools all together at the same in the same week at the same venue, in order to, for instance, facilitate cross-working group discussions on how to compile there. But nothing is said before we are in that discussion. But the baseline assumption is we will make it stackable. We will make it combinable. That is the baseline assumption we work with now. But of course, data selection is a big thing. As I said, we do not want to embark too much on skewed distribution between global north and south, but also we do realize that, for instance, vulnerability data can also be, sensitive because it's disclosing a lot of your socioeconomic vulnerability patterns, etc. It's not trivial to expect that all these data are there. A lot of that data is also behind paywalls and in the hands of private industry, etc., like insurance or asset management. So that is a tough discussion to be made as well. What is actually a credible source of data? We are already thinking about the hosting. We were so fortunate in AR6 that there was this settlement with the Spanish government and the University of Jose Manuel that actually had a tremendous in-kind contribution to the whole development portal, with a chapter scientist and the infrastructure and all this, everything. We were so well serviced as an author team, and we would like to give our authors the same kind of servicing, of course, before they start, because everything is time constrained and we have to be good. So we're already discussing potential infrastructure and maybe financial ways for that. Yeah, and another fun part of it, of course, is what kind of functionality do we actually expect? What is actually the kind of user journeys that we can expect to go? I mean, I heard from the audience it's a hugely appreciated tool for education, which I can confirm. But there is also quite a lot of countries that use the Atlas actually not for detailed climate services, kind of planning or zooming in. But at least it set a context for which national and subnational adaptation planning is given, a motivational support and a graphical motivational support works quite a bit better than to have to cite from a 2,000 thick reports that these and these factors are of interest. So even if you're not diving into the very detailed specifications of the local city that uses it, these local cities do use it to get, you know, a support for that. And I think we need granularity to dive to the fundamental questions of distributional elements of particular risk and coping capacity. If we cannot make a next step in the distributional mapping and stick to the continental scale mapping that we did so far, I don't think we make the progress that we should. I think that is what I'd like to share, and I'm open, happy to stay on for discussion. I understand that you're going out for drinks, and I would be very happy to be there, of course. But I'll stay on as long as is necessary. Thank you for the attention, at least. Thank you.
Thank you, Professor. Actually, we're a bit short on time, but let's see if there is any question here on the audience. Or online, Carlo? Oh, there's one here. Okay.
Okay, thank you. Thank you very much for this great presentation. I'm Chiara Cagnazzo from ECNWF. Thank you very much. It looks quite challenging, what it will come. And my question is about data that are non-climate data, so those exposure, vulnerability, and adaptation policies. I think that your sources of data will be very variegate and different. So the question is, how do you think they could really together coexist in the same interface that as this global, let's say, global objective, and not just in a technical sense, but I think that the sources of data will be different in terms of maturity, reliability. So the question is how to make it homogeneous in this kind of global interface. Thank you.
No, that is a very fair question, and that is of course also in the minds and hearts of all the work group 1 or 2 people. Can we get to the same level of standardization as we are used to in the work group 1? And I don't think we can, because there's way too many dimensions that we need to cover in these social and ecosystem layers, etc. But we do make a scientific-based assessment. And also, don't forget, also these burning amber diagrams that are very famous to show how risks actually evolve with different, warming levels and other attributes. They are based on solid evidence of quantified risk assessment. And also we can also think of a lot of risk assessment activities in European countries, where in my own country, the Netherlands, there is a very solid evidence base, not only on the hazard profile. Actually, our coastal defense protection hazard is the least of interest. It's all about cost. It's all about how many people are being protected. It's also about what are the rescue areas where people can go after a flood event would happen. And that all is based on solid data, on demography, on economy, on that kind of thing. So my gut feeling is we more than in the hazard profile, we do see enormous differences in coverage of high quality data. That is definitely a challenge. But in many contexts, decisions and risk information is being produced on evidence-based data, and it's our job, I guess, to chase what is being used and what has been good enough to also support an adaptation development plan for Bangladesh, for instance, and use that data in this layer. And so. Variability of quality, but I wouldn't go for it if I wouldn't believe that there is at least a minimum level of robustness that we can produce, because early assessment also have been able to produce an evidence-based assessment of where risks are.
Okay, we're going to have one last question.
Yeah, Suraj Desai, can you hear me, Bart?
Yes, I can. Yeah.
University of Leeds. You in your slide you had the technical guidelines, the update to the technical guidelines of 1994. I wonder whether you could say a little bit more about how far they will go. I guess I'm connecting it to the previous question, because I guess the IPCC has traditionally had, countries as their main client, but there'll be a lot of people very interested in these guidelines around impact and adaptation. So could you just say how far that'll go? Will it be, for urban planners, or is it for countries? And in particular, then, I guess, what is the role of climate information in these guidelines? Thanks.
Yeah, there is so far not a very strong connection between the guideline scoping and the atlas scoping. The guideline is indeed has the purpose to service a very large range of the potential practitioners that need to make sense of the risk assessment and the adaptation options or mitigation options. No, it's adaptation, of course, and residual risk and also that kind of things. And that is very context specific. So the guidelines actually assume that every case is an individual case that needs local context specific information. So that's also why the guideline, it opens with a very thoughtful exploration of what is actually your current challenge and what is your current desire, what is it the kind of society you are actually working in and for, before going into the more technical details. And so we didn't design these guidelines with the purpose to homogenize impact monitoring or adaptation monitoring. Although we are fully aware that, of course, UNFCCC global goal has the ambition to come to this uniform reporting kind of tool. We don't know yet where that will go. And what we, for that part, have decided is not to embark already what the outcome of the global goal and adaptation discussion will be. As you know, the discussions on the metrics is still going on. We need to hope that in the Belém conference later this year, there will be some conclusion on it, but we don't know. And so we decided to plan for an expert meeting on adaptation and impact indicators and metrics in March next year, to take stock of what actually the UNFCCC community actually expects from the science world, and what we as a science assessment agency can deliver. So that is the story behind the guideline. And so that uniformity, I know that there is a desire for that, but we didn't design it as such. So the atlas, you see it in my presentation, I didn't refer to the guideline. I'm sure that when we work on it, there will be cross-fertilization, there will be links, oh, this is handy, maybe we have this kind of scenarios as a baseline for the guideline. Well, that is of course nice to have, but we have to see how that will develop.
Okay, thank you, Professor. Please give him an applause. Thank you. So now we're about to start the last thematic session, which is C3S national uptakes. After this, you will have and you will enjoy a wonderful evening here in Valencia with a temperature around 24 degrees and, of course, an icebreaker event. But first, Cristina Ananaso from the ESMWF will provide up an update on the national collaborations programs. Back to you.
Thank you. And indeed, you have a very tough task to keep you awake and pay attention to the very last session. So I will keep it short. I have been asked to keep it also dynamic and interesting like the previous ones. It's really challenging, almost impossible compared to the other speakers, but I try to keep it short at least. I'm not a scientist, sorry for this, so I will give more a programmatic presentation on some action that we put in place at ECMWF to improve our collaboration with member states. So I work a lot in this context with Sam Almond. I don't think that he's around, but he will come soon, and with Delphine, but also with a lot of other colleagues where we are asking for their support or giving them some indication on how to better respond to some national needs. Okay, let's start with these 4 pillars for the national uptake. The first one is, indeed, we want to better understand which is with who are our users and what they really want. So what we call user intelligence, our intelligence to better understand their user. We do it organizing session, using interaction session that lasts for a few months, asking to national users which are their needs. And Andre, after me, will give a presentation exactly on this. And if you are interested, on Wednesday afternoon, you can attend the National User Workshop with the Spanish community organized together with IMET. The second action is what the proper action on national uptake for core users. So these are our focus user. Core user has the definition in Copernicus, so national administration, policymakers. And with this, we have a lot of bilateral meetings with the countries to have a dialogue with them to better understand their needs. We have the call for action. We had one in 2024. We are going to have a next one in the coming few weeks. And Sam and Delphine organize a session on Wednesday morning to better explain which is the interaction with the countries and which are the action that we are going to, the call for action that we are going to publish soon. And then in the afternoon, we have the C3S NCP Forum. That is a side event of the General Assembly. And also in this case, we use this meeting to continuously collect feedback on C3S, feedback on the NCP, but also new requirements. Then indeed, the training is one of the key user requirements that we continuously get from our user. So we closely collaborate with Chris, and he is following us in our discussion, and he really provides us a lot of support. And he has a demo session during the coffee break, so if you want to join him and to listen to what he's proposing for our countries, but in general for the user. Then last pillar of this action is the application and workflows on demand. We just started to do this, so we brought back some needs, and in parallel, our colleague Chiara and Sean are working, for example, on water, and we know that water is a really an important aspect, an important needs, water management coming from the country. So we start working together with our colleagues, and we organize 2 expert workshops on water that will come later this year. Just a brief overview on what is the National Collaboration Program. And today, some of the speakers already mentioned it, the importance of working together with the countries to co-develop together with them solutions that are really needed at national level, even local level sometimes. So we found activities that we define internally, or we provide them with a high-level description on what we want to do, but it's really up to the country to design and to develop the implementation of what they want to do. So through contract and in the future through grants, our contractor has to reinforce at national level the use of C3S products. They can also contribute to existing C3S activities, because we use this feedback to improve our service and to somehow also to design the evolution of the service. It's very important for us, the feedback that we get from the countries on our product, to assess the quality and the fitness for purpose to use at the national, regional, or local level. Then we want them to integrate the C3S products in their workflow, in their everyday operation, potentially combining them with the national products. And another important and key element is the communication. We want the country to communicate at national level in national language. And this is really a kind of game changer in this approach. This is the story so far. So everything started in 2023 when we shared a survey with the delegates at the Copernicus User Forum. We collected their input. We defined some of the priorities for the countries. And based on this, we delivered the first call in May 2024. Then we continued the collection of needs. Then through the NCP Forum, on Wednesday, we have the third meeting of this forum. Bilateral meetings that we have with the country, as already said. Then with the user interaction session, the one that Andre will present, and then also based on C3S priorities, obviously. So what we have done, the first NCP forum in June 2024, then in September 2024, we had the first NCP contract signed. Then the second meeting in November with 27 countries attending. And now we, as I said, we have the third NCP forum. And then at the end of this month, we should also come out with the second call for action, that in this case will be call for proposal because we are going to use grants. And on Wednesday morning, there will be a presentation to explain this not new, but new for ECMWF tool to better improve the collaboration. So far, we signed 9 contracts with 8 countries. And as you can see from this list of not only C3S products, but also priority area, we really try to align the project to the country's needs. And this is also a kind of response to a couple of questions that were asked before. So, for example, in Spain, file and draft management was one of the needs that were raised during the discussion, and they presented a proposal exactly on this topic. For Romania, for example, is agriculture. In Greece, we have renewable energy. So we want to respect and we want to follow the countries within their interest. So that's it from my side. And now I give the floor to Andre.
Thank you, Cristina. Yeah, so following Cristina, Andre Obregon from the ECMWF will discuss the role of national workshops in order to identify national needs and ensuring that Copernicus services are aligned with real-world requirements. Andreas, please take it away.
Good evening, I should say. I know it's late. I will be very brief, I promise. So the cocktails are waiting. So I will focus on this first part of this diagram that Cristina was showing of the national uptake, so which is what we call user intelligence. Very briefly, this overview, it started last year at the GA in Brussels with a national workshop for the Belgian user community. Then earlier in this year, we had an interaction session with Poland, followed by an event with over the Alpine region, which was a transboundary event in March. This week, we will have the Spanish User Day on Wednesday, and we are in good talks with the Czech Republic to have a user workshop later in the year, together with the Czech National Copernicus Forum in Prague. Basically, we're doing these events to foster uptake of C3S products and services, collect user requirements. We use many different channels for this, but this talk is focusing really on these user workshops, and also basically to enhance our understanding of the users. We're doing this together with a contractor who's supporting the events. It's led by Wageningen University. So the first event that I mentioned was the Belgian user workshop at the GA last year, together with the Belgian Science Policy Office and the Belgian Climate Center. It was a relatively small event with 15 participants, but it was quite useful. It was really a mix of different sectors there with different experience, good discussions, various case studies were presented, and we collected a couple of requirements there. The webinars with Poland, this was an online session in the beginning of the year together with the Institute of Environmental Protection in Poland. So there were 2 webinars. One was more on new users, and the other one was more on experienced users, informing them about new features in the climate data store. It had a very, very good uptake. There was 173 unique registrations for these events. The first one, 131, and the second one, 88. And we collected quite a bit of user requirements in these sessions. Then later in the year, in March, we had a transboundary workshop with the Alpine region. So that was together with the Alpine Convention, which is a political treaty dealing with broad issues in the Alpine region. And they have, well, climate change, of course, is one of those issues. And they have a climate board that we have been liaising with. And when we plan these user interaction sessions, it's not just one-off event. So it's basically a series of engagements. We had a couple of bilateral meetings with them. We run a survey across the climate board members to inform the workshop. And then we organized this online workshop together with the user community and had a good outturn as well for this event with 60 participants. Different thematic areas were covered, such as biodiversity, natural hazards, infrastructure, and tourism. As promised, this is my last slide already. Just to inform you about this user day on Wednesday afternoon, I think it is, on the second floor, co-organized with IMED. Fernando Belda is here as well, speaking after me. There are still spaces available, so if you're from Spain, if you're working in Spain, feel free to drop in. It's not by invitation only, so everyone basically in the room is welcome to attend. I stop here. Thanks.
Is there any question here in the audience or online? So we'll let you go. Thank you. So finally, Fernando Belda from IMED will share insights into how Spain has benefited from the national collaboration programs and how Copernicus services are helping the country respond to climate challenge. Fernando, welcome.
Okay, thank you very much, Mark. Thank you very much, Carlo, all climate change services team to invite to be here in Valencia, in my city. I need to say this. And I don't know if I cannot promise I will be short, and then I will try to explain some slides, but because I know that the icebreaker is waiting us, and then we need this icebreaker. The idea, because during this afternoon there has been raised important concerns that we have regarding what is the connection between the local needs, national needs, with the Copernicus is doing. What is our task? At least my task, I will be jumping between National Medical Services and the Copernicus User Forum delegate, and then trying to manage these two roles and trying to manage what is the requirements that we need to translate to Copernicus to ensure this important alignment. This is the presentation. First is before explaining this, I need to say that these presentations, I will try to collect a lot of slides coming from different organizations, because and now I'm talking about the Copernicus User Forum. There are a lot of organizations involved in this. We are trying to define the best mechanisms to ensure that we are collecting the requirements from all users. And probably I missed some organizations in this slide, but anyway, in the icebreaker I can explain the details about this. Okay, and then the first is some slide regarding the Copernicus ecosystem for Spain, following our fathers, I say, the climate change Copernicus in Copernicus services. What the principal requirements and the strategy lines, I will move quickly in these slides because obviously we have time to discuss, and then we have some posters that you can check with some details, and then I'm available, obviously my team that is coming from IMED, that a lot of people involved in these activities, not only from IMED, obviously coming from other organizations. How are we managing this, the governance to ensure that we can collect this information? We have a couple of examples about the NCP. I agree that the NCP is a good example of how can improve our services in our cities and how can enrich the products and the services that the Copernicus Climate Change is doing. I think this is an excellent opportunity. It's not enough. We need to do more. But anyway, I think this is an important aspect that we need to enhance and we need to support, because behind this, is necessary money. I want to say clearly the budget, and then we need to ensure that all organizations, we need to be efficient. That I will say something about this. And obviously the future climate change is regarding how many, because in the focal point that we have in different organizations is clear to get what is the thought that they have regarding the future of the climate change services. This is a courtesy from the Institute, Hydrology Institute for Cantabria. They are working excellent work doing, and then you can check in the map how many actors we can involve only in Spain, how many sectors have been involved, and then how can connect them. This is important. I forgot to comment one important aspect for me, at least for me, because when every day, especially after the data that we have here in Valencia, and the question that we need to answer every day is that what can we do to support emergency unit, an emergency extreme event? This is the aspect that we need to follow. Here we are in these 3 days, we're talking about the climate change services, but I will talk about the Copernicus in general, not only the climate change. This is the principle in the left side. I think it's clear that is important. Some of these words has been raised this afternoon, and then I want to repeat that the visibility, we are working to improve the visibility of the Copernicus, to establish a good collaboration between the public and the private organizations. We talked this morning to ensure the link between the research and the operations. We'll try to do this and to link the service and operations. There are a lot of cross-border activities. We discussed several times with a lot of organizations to ensure that the cross-border activities is request currently, and then is that we need to understand. And now I'm thinking about the emergency. I will repeat several times about this. Transfer of knowledge, we are talking about the education and training. We're talking about some questions in the session this afternoon, say something about this, what is important, the education and so on. I think this is important to clarify this. National Medical Services, IMET, is working on it. We have an important project. The name is Medina. I'm sure that Mark knows this, but who is Medina? But Medina is important. This is an important project to transfer this knowledge in the schools and the universities. So the most important in the schools, I think they need to understand. Innovation activities and obviously the communication. Communication is to explain. We need to explain what is happening. We need to explain who is Copernicus, what is explain the work of the Copernicus, and what is the synergy that we have. To summarize, this is the domain. This is a lot of synergies between the services, and what our work is to put all together and to focus our work in a sectors. We are talking about the energy, health, power cost. It doesn't matter how many sectors is need, but this is important for us. The strategic line that you can check, we can in clockwise, it doesn't matter what is the order, but obviously we need to find the mechanism to ensure a good alliance between the different governments, local, regional, and local, national, and regional. I think is really, really important. Looking the efficiency of the investment that we are doing, and looking obviously the real requirements that the local needs. And this afternoon, Carlos said regarding the authority voice. I think that we need to promote this. We need to be the echo about this voice, and to create solutions in specialists, to promote the use of marketing, to promote the use case. That this is the next example that we can share with you. And obviously, knowledge transfer, that you already say this, and improve the skill of the users to understand what is the product is offering. This is the big map about how many organizations have been involved in the different services, who is who in different Copernicus services. Obviously, in the National Medical Services, we are involved in camps and in climate change, but there are a lot of organizations that now I put the hat of the Copernicus Forum. We are working hard. We are working hard with them to ensure that we are well connected. They are well connected. And you can imagine it's National Geographical Institute, Civil Protections, the security and Puertos del Estado, the different organizations that we're working together. It's important, but it's important for the mechanism, not for the names that are there. And the important is that we have two focal points that we are working. We have one focal point by services, and at the same time, we have an Extend Copernicus User Forum. That Extend is include everybody can be in this Extend. And then it's not easy to manage these meetings, but to be honest, we enrich exactly what is the important. The future evolution, obviously, it's the thematic contact point, and then this is we are defining the focal point by thematic sector, and they are offering this. They are sending us the exactly what is the requirements, and they will trying to establish this bridge between the services that they can offer, or maybe they do promote. One example is on the NCP that we talked about the NCP several times. This is a real case in the camps. It's camps, it doesn't matter, but this is another backbone for us, exactly. And this is one example about the air quality index, that the benefit that we can have when we are working join the Copernicus services. Another example about the skills of some specific products that this morning to say the blue color is the important and then the blue color is the right side. I remember this expression, but anyway, this is one example. This is working. This is a real product, and then we started in shipping camps 2 years ago, and then this is a product that they are offering, and you can check this in our webpage, and then what the information can be. What's happening now in climate change? Obviously, we are working joint the Spanish National Research Council. This Jose Manuel is leading this NCP, and we are working on them. But obviously, our framework is the Climate Change National Adaptation Plan, and then we need to move this. I don't know how many organizations we are involved in this, and the idea is to coordinate and ensure that Jose Manuel can explain better than me exactly how it's going the aspect. But Cristina explained what the priorities that now we are working. Obviously, this is a map that what are we doing. Now it's in the National Meteorological Services, but I'm sure that in the poster that you can check, and maybe in the slot tomorrow, you can check additional information about the NCP. In the last two slides, I promised the last two slides, this is the questions that when we had the meeting, the questions about what is the concern of the focal points that we have. Obviously, there are a lot of improve it. It's normal. We need to improve every day, and then it's not an issue now. But this is obviously the concerns of the different sectors has been involved when we are getting the climate change, and then it's important to analyze and to measure exactly what is the meaning about this. But you can imagine artificial intelligence, machine learning has been set up during this afternoon, and obviously institute observations has been shown with this presentation during this afternoon. And finally, when we're talking about the cross-cutting activities, because I would like to finalize the presentation, at least to highlight what important is now in our site, that we are working joint emergency units who can collect what information is important for them, because they need to take the decisions that they can save lives, and then this is important for us. And these different bullets that you can check, and then you can check at the same time in the poster. But another question that has been raised is the connection with Destination Earth. And then I want to finish this, and somebody need to ask where this. Thank you very much.
Okay. So, is there any question to Fernando?
For me? Well, you said you wanted the question with Destination Earth. Yeah, no. I put this question, but I have not the answer. Maybe after the dash break, I think is a better moment.
You can do it.
That we say in Spain, after a couple of cups of wines, I think we can talk seriously, and then there's a problem. Thank you very much.
Okay, So give him an applause. Thank you, Fernando. So the sun is coming down already, and I just want to thank you once again to all of the incredible speakers and to all of you to participate today. It has been a pleasure hearing from the experts who are shaping the future of climate monitoring and services. Their contributions are vital to, as we face the challenges of the climate change. I also want to thank Copernicus, the Copernicus team, for creating this space that we can do such an important discussions. This assembly demonstrates the power of collaboration in addressing the climate crisis. So thank you. And now, just invite you to join us to the evening reception, this icebreaker event. So thank you once again.